Good morning, everyone. My name is Samia Touileb. I'm an associate professor here at the University of Bergen, and I am very happy to welcome you all today. And I'm very happy to see so many here, despite the weather. I had this the same seminar 2 years ago, and I said the same sentence, but the weather was dreadful. And today the weather is amazing. So yeah, I mean, people stay home when the weather is horrible and go out when it's super nice. So I'm happy that some of you came here. So thank you. The focus of today's seminar is on AI alignment from a very general perspective. So we all know that these AI systems now are being used everywhere. They're being introduced and deployed and have become part of our everyday life. And ensuring that these systems actually align with us, with our human values, with our long-term goals is one of the most pressing issues, I would say. But it doesn't only challenge AI in general, it also challenges society, because this is something that actually impacts all of us. So AI alignment, I forgot that I have a presentation of also Doug. I'm sorry, Doug. But yes, let's rewind. Forget everything I said until now. So this is me, and this is Doug. Doug has been helping me with everything, so thank you so much, Doug. We are organizing this thanks to Bergen's Universitetsfondet, or the University Foundation of Bergen, and also the Momentum program, which I was a delegate in 2 years ago, I think, and of course UiB AI. So they all have helped us create and fund this event. So I'm really grateful for that. So okay, now we can move on and talk about what AI alignment is. So AI alignment actually focuses on guiding AI systems to achieve the goals, preferences, and values, societal norms, and ethical standards set by individuals or group. So we have humans on one side, and then we have the machines on the other one. And the entire idea is that we would like to represent all of these. We would like to represent the values, the interests, the desire, the preferences, the intention, and the instructions of the humans in these machines. And the goal of alignment has been defined in different ways. So you have the instructions where you would like the agent to actually do what it is instructed to do. You have the intentions where the agent does what I, the user or the creator, intended to do. Then you have the preferences where the agent does what my behavior reveals that I prefer. You have the desires where the agent does what I would want to do if I were rational and informed. And then you have the interest, where the agent does what it is in my interest or what is best for me, objectively speaking. And then you have the values, where the agent does what it morally ought to do as defined by the individual or society. The problem is that who should we actually align these systems with? Which values should we align them with? I mean, we're all different. We all have diverse and sometimes conflicting thoughts, preferences, even maybe values. And it's very difficult to kind of seek one single goal for all of us and represent all of us when we're trying to align these systems. And also it's very difficult to fairly combine individual views and develop compatible alignment principles. So today we will explore some of the technical challenges, but also what it means to have AI systems that are aligned with human values, from very broad ethical, legal, societal, and of course technical perspectives. We have an amazing lineup of experts who will share their thoughts and insights and research on different aspects. And I'm very, very happy that they all agreed to come and that they all agreed to give a presentation. We also have two who came back from last time, which is Jan and Davide, which is also something I really, really am happy for. All right, so we start with Tom. Tom is a machine learning engineer with the AI research team at BBC. His work focuses on the development and deployment of AI and machine learning systems at the BBC to enable high-performance model training for BBC tasks. His primary areas of interest are machine learning engineering, AI safety and interpretability, and content provenance. And then after Tom, we have Leonora. who is an associate professor at Østfold University of Applied Science and the University of Agder here in Norway. Her research focuses on the responsible and ethical use of AI, with particular emphasis on methodologies of ethical risk assessment of AI in real-world practices. She has extensive experience working with ethical frameworks, research ethics, and interdisciplinary collaboration related to AI in education. And after that, we have a coffee break, where you can think a little bit about everything that you've heard so far. After the coffee break, we have Rune, who is an associate professor at the Center for Science Studies, Aarhus University. His research focuses on interdisciplinary AI ethics and the philosophical foundation of responsible and trustworthy AI. He also teaches philosophy of science and ethics to all bachelor students at Aarhus in data science, computer science, IT project development. So before coming to Aarhus, in 2023, he worked for 7 years as a research fellow at the Center for the Future of Intelligence in the University of Cambridge. And then after Rune, we have Jan, who is professor of logical methods in AI. He has a background in mathematics, logic, and computer science, and he studies AI from a humanities perspective. And his main interests are responsible AI, knowledge representation and reasoning, and logic theories of agency. After that, we have lunch that is free and included, and I hope that you will enjoy it. Then we will have a rather long break for the lunch, 45 minutes. And then we come back, and in session 2, we will have another focus, which will be law, interpretability, and deployment, where Holli will start. And Holli is a research fellow in law at St. John's College at the University of Cambridge. Her research examines the intersection of law and AI, with a focus on how algorithmic systems used in high-stakes decision-making affect fairness, discrimination, and accountability, and how legal frameworks may adapt to support responsible and ethical AI governance. She has a PhD from Cambridge and has been on research visits at Harvard Law School and the Bergen Clean Center. And prior to working in academia, she actually practiced as a solicitor and worked with the Australian Human Rights Commission. And after that, Davide we'll talk a little bit about mechanistic interpretability, and Davide is a postdoc researcher at the University of Luxembourg. He contributes to the CLAIM, computational law and machine ethics, and the individual and collective reasoning research groups, and he works mostly on interpretation, alignment of LLMs, and a lot of very cool things. And then we have a new coffee break. And after that, we have Davide from the University of Oslo. He is also a postdoc at the research technology group there, and he specializes in data constraint pre-training and post-training of LLMs. And he is actually, I don't see him, there he is. He is actually one of the people who have trained most of Norwegian LLMs. So if you're interested in Norwegian LLMs, you should definitely talk to him. And at last but not least, we have Ryan, who also is a postdoc at the University of Oslo. And his work focuses mainly on machine learning for cybersecurity, but also AI security in general. And after Ryan, we will have a panel discussion where we will kind of wrap up all the ideas we hopefully have learned from everyone and discuss a little bit what does it actually mean to align AI, and can we really build systems that we really truly control. Each speaker will hopefully might have some time for questions after their presentation. If not, you can all send your questions here, and I can ask them for you during the panel discussion before we open for more questions. So yeah, great. Thank you so much, everyone. I'm really looking forward to this, and our first speaker is Tom, so welcome.
Sure. Hello, everyone. Thanks for the introduction, Samia. I don't know. Yeah, OK. Here we go. As Samia said, I'm from the BBC, specifically the Research and Development Department in the AI research team. And today I'm going to talk to you about how we are building and deploying AI models at the BBC in a responsible, safe, and aligned way to enable our journalist teams and content creation teams to do better and more work. So first I kind of talk about what is the kind of AI alignment problem we are facing at the BBC. So in my team, the AI research team, as I said, what we do is we kind of build models and deploy them for tasks that our journalists or content creation teams might be facing, and whether that's for making their work more efficient, allowing them to create more items, or freeing them up to do more creative things. But because we're the BBC, there's certain constraints that come with that. We're the biggest and oldest public service broadcaster in the world, and that public service kind of values and ethos has to be at the heart of everything that we do. And that's not just a kind of motto that we're kind of putting out there in the world. It is also something that's kind of ingrained into our constitution. So the way we try to capture these public service values is under these kind of three big slogans here, which the first of them is what we refer to as pursue truth with no agenda. And this is around our mission for accurate news, impartiality, reporting on what's going on around the world in a fair way. We also have backing British storytelling. So we have a big mission to kind of show the diverse range of stories and perspectives across the UK and kind of help out the UK creative economy and set industry standards for other broadcasters and content creators across the UK and also the rest of the world. And we've also got this side of our work around entertainment, bringing people together, inclusivity, all of that to kind of bring the country and the world together around big events. So as I said, these are not really just marketing terms. They are actually part of our constitution. We have kind of a royal charter, which lays out the legal mandate for the BBC, basically. And we also have editorial standards and policy, which set how we should do all of our work and the standard it should be set to. We have our internal BBC values framework, which defines all of our metrics for working against in internal projects. And we also have things like style guidelines, which set out how our tone and style of output should be. But how do we take these values documents and use them when we're building AI models? So if you imagine here, we've got this simplified training pipeline of how you might want to build an AI model. So in this case, I've shown an open source model from Mistral AI. How do we take that model and use BBC data to train the model for a BBC task in a way that incorporates these BBC values and ensures that any output that goes to our audiences is aligned to the public service mission of the BBC? And that's the kind of question that I'll be answering today, or hopefully trying to attempt to answer today in this talk. And I will cover the kind of main development approach that we take to building AI systems within my team, and that covers the full pipeline of AI development and deployment from your model and data selection to your training and evaluation, right down to deployment and what safeguards and guardrails we might want to put in place there. And these can kind of be grouped into three main pillars, which I like to call sandboxing, training goals, and provenance, which kind of show you the progression through the pipeline of training to deployment. So first, I'm going to talk a little bit about sandboxing and what is commonly referred to now as sovereign AI. If you've been to other conferences in this field, you've probably heard the term sovereign AI bandied around a lot recently. So I wanted to get it in there to show you what we're doing around that. So when you are trying to apply AI and machine learning within internal system, or someone comes to us and we're given a task that we need to use AI to complete or try and build a system for a BBC task, you're always faced with two main options, really, which is often referred to as the build it or buy it approach, which you've probably heard. The buy it approach is probably the easiest and fastest way to get AI systems out there into development, and this kind of depends on working with commercial model providers like your OpenAI, Anthropic, Google, people like that, which you can access their latest state-of-the-art models through their APIs. And this comes with certain benefits. As I said, it's easier to get things into deployment, and it makes your work quicker and faster on that side. You're also getting access to these frontier models. So they're often very, very good at a lot of tasks and don't need you to do anything to them to do that, to get that like high level of performance. But there's a caveat to this of there are certain issues with using these commercial models, as I've kind of outlined here, especially when you're looking at this from a public values perspective. So these commercial model providers, they're not incentivized in the same way public service broadcasters, say, like the BBC are. They focus a lot on things like engagement and making sales and driving revenue, which obviously are not public service values. So they don't really have that ingrained into the core of their AI strategy. There's also a lot to note about data privacy and where our internal data would go and how it would be used if you're feeding it to these models, and any user data that's coming from our audience, which is obviously something to consider. When you're using these external models, there's also kind of an element of mystery to it, as you don't know exactly the architecture or the training data that's been used for these models. And this can lead to things like model drift, where changes to the model or its outputs can have downstream impacts on the system that you've built. And this kind of hits on the general theme of you're outsourcing your models, so you're getting this dependency in both an economic and technological way to these commercial model providers. So what's the other approach? This is where the sovereign AI side comes in, or the build it side of things. And this is kind of building on an approach of sandboxing your training and models and data together into an internal live environment. Internal kind of development environment, and then you have a live environment that you can move models into. So what does this entail? You kind of have a choice of building your models completely from scratch, which is one way of going, building all of the architecture and everything on that side. And also, or you can go and use open source models like the Mistral AI that I showed earlier, and take them and tune them to your own domain. And this gives you a lot more control over the size of your model, the architecture, and also the data it's trained on. So you can kind of have finer grained control about how the outputs are generated and what they end up producing for a user or the audience. It also gives you a little bit more visibility over the lineage, so you know what data has trained which model, and you can safely progress models into a live environment when they've been rigorously evaluated. So that covers the kind of foundational layer of our AI development strategy, which sandboxes this development approach. But once we have our model and our data, how do we go about training a model so that it ingrains these BBC public service values? If you think back to my slide about the constitution of the BBC, the kind of approach can be distilled into these three main goals, basically, that we want to ingrain into our system. The first of which is factuality. So this is around your accuracy of outputs. So we don't want to be generating hallucinations, which is obviously a big issue for LLMs. We want to adhere to any kind of ground truth inputs that we give to a model. So if you give it a big document, if you're extracting any summaries or quotations from that document, you want it to be completely truthful to any inputs. And when we produce our outputs from a model, we want them to be up to date, contain citations, and have facts and figures to justify anything that it is outputting. We also have our goals around impartiality and representation. So we don't want to introduce any bias, and we want to include a diverse range of viewpoints and represent everything across the UK, our regional voices, in a fair and balanced way. So I will kind of touch on each of these training approaches that you can use. I'm sure in later talks people may touch on some of these as well, as they're kind of big pillars of the AI alignment space. But here are some ways in which you can ingrain these value systems into a model at training time. The first one that we sometimes use is something called direct preference optimization. And it's basically you use a human evaluator to construct a preference data set, showing the model we would like responses that look like this, and we wouldn't like responses that look like this. And when they create that preference data set, they use the BBC values system to guide what responses would be preferred by a model. And when we take our, say, open source model off the shelf, we can fine-tune it on this preference data set using DPO to guide its responses towards those preferred answers, which hopefully are more aligned to our value system. You've probably also heard of reinforcement learning with human feedback, which is a big topic in this space and kind of gave rise to the recent GPT models and ChatGPT and allowed all of this stuff. And this is also using human evaluators, but using that signal as a reward signal to conduct reinforcement learning, as the name suggests, so that we can guide the outputs of a model towards our value-aligned answers. There's something around constitutional AI as well, which people also refer to as RLAIF, which is AI feedback reinforcement learning. But I won't delve too deep into that. It basically uses the model to generate its own AI feedback of the responses that it's making instead of using exclusively human evaluators. And we can use techniques like this to define our constitution of public service values, which is basically a document of principles that we want to guide our model to follow. This might be something like you have to be impartial, you should always cite your answers from a source text, you have to represent all views, things like that. And using these techniques, we can try to guide the training process to stick to this value system as much as possible. So training time is not the only time that you can try and align your model. There's also inference time approaches that you can use during evaluation or even at deployment. So a couple of these I like to go through are something called constrained decoding, which is a personal favorite of mine. And if you've ever used a commercial model provider and used their structured output format, this is how this works, basically. So you look at the model's output tokens, in the case of an LLM, and you constrict that vocab down to some structured system. So in the case of structured outputs, you might want to produce a JSON document. And in that case, you can constrict the token space of a model so that it always outputs valid JSON. In our case, we care more about things like quotations. So we can also do a careful bit of processing at this level to make sure that when a model is outputting quotations, it looks back to an input source and only outputs quotes that are exact verbatim copies of what was in any input text. If you look at the diagram on the side here, this is another approach called best of n sampling, which is basically where you get the model to generate a whole load of candidate answers for a given query. You score these answers, and then you pick the best one, which is something that we try and use a lot due to the randomness of model outputs. And these last two are kind of self-explanatory, but we have LLM as a judge and human in the loop. So LLM as a judge is an approach which we like to use, which basically looks at answers after they've been generated and tries to flag any kind of hallucinations, misalignment, or inaccuracies in those responses after they've been shown to, say, an internal user. And this is done with a different LLM than the one that may have generated the answers so that we get that differing perspective. We also have an approach of human in the loop at the BBC, which is kind of going across all of our work in AI at this moment, as we never automatically publish AI-generated material to the public. We always have a human journalist or a human editor looking over that work to make sure there aren't any glaring errors and hopefully correct any that do happen. So that kind of covers our main training and evaluation approach to models and data. But once we have our trained model, how do we deploy it in a safe way? And this is where I come on to provenance, which a lot of the work within BBC Research and Development is around this area of safety. So, as I said, we want to kind of make sure that when a piece of content is published to an audience, or when that content comes through our internal systems, we can easily distinguish between AI-generated content and something that's been made by hand by a human. The first way that we like to do this is always labeling AI content. So if you see this screenshot in the corner at the bottom, we always use this AI label on anything that's used AI to help edit it on the BBC website. So here we've got how I used AI, and it discloses to the audience that AI-assisted writing has been used in this case. The other big piece of work that's come out of BBC R&D is C2PA, which you might have heard of, or content credentials, as it's sometimes referred to. And this is a media standard for embedding provenance information into content, whether that be images, video, audio, or even now text-based formats. And what this does is it enables you to carry a rich provenance trail within a media asset itself, so you can mark information about what tool created a piece of content, what edits have been made to it down the line, and that can be recovered and looked into when you kind of find the piece of content either online or on some kind of social media site, things like that. But C2PA isn't the only way we can mark our content to make sure that it is safely retrievable and identifiable online. There's also this approach of watermarking. And it's good to use this kind of belt and braces approach of dual C2PA plus watermarking. So C2PA gives you a rich, detailed provenance trail, whereas watermarking can embed a robust signal into the content that's hard to remove and can stamp it as originating from a certain tool. So this is quite common in the image and video domain, as you can just manipulate values of the pixels a little bit, which you can then later reverse engineer and pick up within the content. However, it's a little bit trickier when you think of text. If we're using an LLM, how can we watermark that text so that it's identifiable down the line? And it's kind of got similar ideas to the image visual space, but changes that a little bit. What it does is, when we're looking at the outputs of an LLM, we make slight changes to the statistical distribution of what tokens are generated in a way that is later identifiable. So if you look at these two texts here, don't worry about looking at the specific words, but you see the distribution of red tokens and green tokens is different in the top text and the bottom, and that difference is hopefully identifiable to pick out your text as originating from some tool. So I'll quickly skim through a little project that we've done in BBC Research and Development that applies all of these principles across the development pipeline to kind of show you how we put this into practice. At the BBC, we have funded this organization called the Local Democracy Reporting Service. And basically what this does is it employs local journalists within regional outlets and offices across the UK and funds them to do local journalism, basically. So reporting on their local councils and public interest stories in their area. Once they have produced these local articles, they're available either to be published by that outlet or published by the BBC or submitted to other journalism outlets to be published. But when we get these local articles coming into the BBC, they obviously don't perfectly match the BBC style or aren't as strict on BBC guidelines as something that would have been created in-house. So often when we get submitted an article like this on the left-hand side, there has to be a journalist or editor who consults the style guide and editorial guidelines to check and edit the article so that it's BBC compliant to those public service values to produce the final article on the right. So how did we employ our development approach to do something like this? So if we think about sandboxing and the sovereign AI approach, we used a model from Mistral AI to do this, an open source model. We took it and we trained it on some BBC data. So if you look at the training and evaluation stage there, this touches on some of the approaches that I've mentioned before. First, we do a bit of supervised fine-tuning, which is your classic approach to training a model to complete some task. But then we do another round of training using that DPO preference-based training that I mentioned earlier. So we get human journalist evaluators to kind of mark which outputs are good according to BBC values, and we do some fine-tuning on the model to make it prefer those BBC value-aligned articles. We also use this inference time approach, which I touched on earlier, and this included things like constrained decoding, which went to get verbatim quotes from the source article, as I explained earlier, and also used that best event sampling approach. And in this case, we used what's called sentence level best event. So to generate each sentence from the model, we output candidate sentences, and then we use another model called align score, which basically checks the factuality of each sentence before it is generated. And we pick the best sentence and then keep going generating the article. So this is kind of how we built out that local article to BBC article rewriting process as an AI model within our space of responsible AI development. So that kind of brings me to the close here. What can we take away from this development approach? And I kind of want to frame this and bring this back to very much a case for hope. So you might think about AI alignment and AI safety and all of the doom and gloom at the moment, and that is obviously quite valid. But there are some good things in this space, especially around sovereign AI and things like that. We have got some capable European open source models that we can point to. I'd always encourage more development in this space, but you can get a lot of tasks done using open source models. There's also, as I showed, been some progress towards value-aligned AI training from people like Anthropic, who came up with this constitutional AI principles. But again, it is quite hard to ingrain quantitatively these kind of more higher-level concepts of fairness and impartiality. So more work on quantifying these things is definitely needed. And especially in the provenance case, there's been a lot of traction very recently around C2PA and watermarking, which is great from people like Google and even OpenAI using both C2PA and Google's SynthID watermarking technique to ingrain provenance into their AI-generated outputs. But this is done in a very closed-sourced way. So there needs to be more development in this space to kind of open that up and make it viewable by end users and the audience. And definitely there's still work to do in the text domain on that front. But hopefully that's kind of inspired you to think about the practical applications of responsible AI. And I thank you for listening today.
All right. We have some time for questions. So if there are any, yeah, there is one there.
Yeah, hi, thanks.
The microphone is coming.
You can also stand up. I have a practical question. When you talk about the impartiality, how do you ensure that you have this? On the radio, normally, in Germany, you have a contract that you have to be impartial, and you do this by having many voices heard on the radio in their own language. So how do you do this in an LLM? That would be my question. And another question is also a little bit beyond your lecture. How do journalists actually use the AI for their reports? Because this is also a very sensitive issue, right? To what extent you can use it in your writing?
Yeah. So I'll start with the second half of your question. At the moment, we're using it fairly sparingly within the journalism pipeline. Obviously, journalists are free to use it for research purposes, but in terms of tools like the BBC Style Assist tool that we've built, there is a few in that side that we have progressed into production and allow journalists to use freely. So with the Style Assist tool that I showed, that is actually embedded into our news editing system, and so it all works automatically through that. And we also have AI tools that do other more kind of efficiency-based tasks like that, but hopefully don't impact too much on the deep investigative journalism and that side of work. Coming back to the impartiality, this is a very, very tough question because impartiality, as you say, is quite a wide thing. If you're looking at the radio, as you said, you have to represent different viewpoints and give airtime to different sides of an argument. And we have that within our BBC editorial policy of we have to give a kind of equal airtime to different, say, political parties or viewpoints on that side. But when we come to an LLM, this is quite hard to quantify. So you can kind of do this by doing some kind of named entity recognition, but that's going a little bit, I don't know, technical too far on that side, and you might be limiting yourself a little bit. When you build things like preference data sets, which I talked about, you can use things like impartiality as your guide. So if you lay out a constitution, kind of like the BBC guidelines that say this content has to be impartial in this way, we have to give equal airtime. When you're generating something out of an LLM or training your own LLM in this case, you can use these principles to guide your preferences and value system. So we might generate a whole load of answers out of an LLM and use this kind of impartiality using, say, a human in the loop or some kind of LLM as a judge to mark, has this answer shown different perspectives or been fair, been impartial, and given kind of equal time to different things. And that is quite hard to quantify, and I wouldn't say it's a completely solved problem at this point. Definitely needs more work in that area, but it's something that we're trying to approach.
Great. I think we have time for one more question, and then we need to move on.
Thank you. Yeah, thank you so much for a really informative and interesting talk, and I'm looking forward to discussing many of the topics with you over coffee. One thing that I wanted to hear more about was something a little bit about resources and capacity. So you're using the open source models, and you hear different stories about how good are they compared to the frontier labs. So one question is sort of, what's your experience? How much can you get out of these open source models? Are they competitive for the purposes you're using them for? And related to that, sort of, for the kinds of projects you're running, BBC is a large organization, sort of relatively well-resourced compared to many other users that might be interested here. So could you share a little bit about, like, how hard is it? How many, like, you don't have to put numbers on it. You don't need to tell me your budget, but how much effort and resources does it take to get these things to work in your experience?
Thanks. Well, yes, the BBC is a fairly large organization, but the AI research team that I work in is like 20 to 30 people, all working on different tasks. So yes, there is a level of kind of resourcing that we get as part of the BBC, but since we're publicly funded, we don't want to be burning through loads of expensive GPUs or anything like that. So I would say, like, GPU and compute, as you probably heard from other people, is one of the main limitations, really, of you need this computing power to be able to do these like long training runs, especially something like reinforcement learning, which needs a lot of compute. So that's probably a big limiter to taking and fine-tuning your own models. But we found that even relatively small LLMs, like the Mistral 7B that I showed as part of this work, can be quite good at kind of isolated tasks. So it's obviously not going to be as general as ChatGPT. You couldn't fine-tune a model on one thing and expect it to be like able to do a whole suite of BBC tasks. But if you have a well-defined problem, which in our case was a fairly consistent mapping between local articles and BBC articles, I find they're quite performant at things like that. And there is quite a lot of active development in the open source model space. Like Google recently released a new version of its Gemma models, which I've been finding are very competitive with some of the frontier models. And there's also a lot of other models going up and down the spectrum. So if you are limited in compute or human resourcing to be able to develop these things, some of the like even smaller language models can do some tasks that you might be looking to do that are well-defined and can be done on a kind of cheaper compute that won't bankrupt you, basically. But yeah.
All right. Thank you so much. We are starting again. Ja, jeg prøvde, men jeg tror ikke det så meg. All right, now you can hear me. We're starting again, and the next speaker is Rune. The floor is yours.
Thank you very much. Yeah, I'm coming through. Right, well, thank you so much, Samia, for inviting me and putting on this event. It's already really interesting, and I'm looking forward to the conversations as we go forward. Yeah, so in this talk, I'm going to share some work. A lot of it is, some of it hasn't been done yet, so it's sort of prospective work. Some of it is very recent work that illustrates questions around how philosophy and computer science can collaborate within the broad space of AI alignment, and in particular on the question of the evaluation of explainability. And I'll tell you what that is in a second. Just a note, it says Department of Mathematics because that's where I'm based, but I'm a philosopher by training, a philosopher of science. And as Samia mentioned, my job is to teach philosophy of science and ethics to computer science students. So because I look a lot like a mathematician to the university administration, I'm based at the Department of Mathematics, but I'm not a mathematician, so don't ask me hard maths questions. Okay. Right, so I'm going to share some examples of how I, as a philosopher, have been collaborating and I'm planning to collaborate with computer scientists. But before I get to that, I want to talk about a hat. The yes hat. I don't know, do you have this expression in Norwegian? The yes hat? Yeah hatten? Okay, no. So it's not a real hat, right? This is AI. This is an AI-generated thing, right? So it's an expression we have in Danish. I have no idea where it comes from. If you're wearing the yes hat, it means that you're sort of open, positive. You're going to say yes. You're going to see the perspective. And you can also tell others, like, oh, put on the yes hat. Like, just say yes. It's going to be fine. And as an academic, a thing you really need to learn is when to say no to things. And I'm the kind of person who often wears the yes hat. So my natural inclination, if people come and pitch some interesting idea, hey, Rune, do you want to come to a seminar in Bergen? I'm going to say yes. That's my natural inclination. And I've spent a lot of my career trying to learn when to say yes and no. But in this talk, I'm going to talk about why I still say yes a lot, why I did come to Bergen, and why I like doing it, because I think a lot of exciting things come out of it. So I'm willing to accept that sometimes I say yes to things that aren't as interesting as today. Okay, so the first thing I'm going to talk about is a project that I got funding for recently. It's just about to launch in July. And just sort of the background story here, it's a collaboration together with Ira Essend, who is a professor of computer science at Aarhus University. And she works on technical explainable AI, which I'm going to say what it is in a second. So I joined Aarhus in September 23. And when I joined, there was a project being developed, a project proposal, not this one. They asked me, do you want to join this? I didn't really know the people involved, but I put on the yes hat and said, sure, I'm going to do it. Right. And this proposal didn't work out. We didn't get the money, but I had good conversations with Ira, amongst other people. We kept on talking. And one of the things we did was we sort of exchanged teaching. So I came and gave a guest lecture in her course. Some of her PhD students came and participated in some of my courses and reading groups. And so we sort of kept the conversation going. And then last spring, we put in a new proposal for a thing with us two, with this thing we called the REMAX project, Rigorous Evaluation Methods for AI Explainability. So that's how that came about. So it's all about this thing called the explainability problem, you might call it. So this is sort of one of the big topics in AI alignment, is the problem that if you have a very complex AI system, it can be really hard to explain and understand why it makes a given decision or how it works, even why it works at all. It can be very mysterious, even to really, even to the people who develop the system, even to expert machine learning researchers. So one of the solutions to this problem, there are others, is to use what's called explainable AI, or just XAI, or sometimes interpretable machine learning. So here's some examples. I've just borrowed some pictures from a textbook here. So there are basically tools that will extract some information from an AI system. For instance, why it classified this picture as containing buns, and then it'll sort of, in this case, this is called Lime, so we'll train a very simple model that's supposed to be locally accurate, and it will say the green pixels, those were the ones that had a positive contribution to that classification, and the red pixels are the ones that had a negative contribution. Another method is SHAP. It's a bit more complicated, but anyway, the idea is you get a pretty picture like this that gives you some sense of which features made a positive or negative contribution to a given output. And there's lots of interesting technical work being done here. But a big problem is, how do we evaluate these methods? So there are all these methods. They do seem to give us useful information, but it's not clear to what extent do they actually make these systems explainable or interpretable. These terms are being used in sort of an intuitive way by a lot of researchers in the field, but there are not very clear definitions. That's both a problem when, as a regulator, you're trying to decide, people say that this is an explainable system. Well, is that true? What evidence could they provide for that? But it's also a challenge for developers. So when you publish a research paper, you said, oh, I've made an improved version of SHAP. And then you want to give some evidence that you've improved the method. And actually, there's a lot of uncertainty in the field about exactly what kind of evidence is good evidence that the method has been improved. So me and Ira were talking about this, and we had some shared frustrations, or sort of complementary frustrations. So in computer science, the kind of evaluation methods, there's sort of two broad directions. One of them is user studies. So you do a prototype, you get some non-expert users in, or sort of representative of your users that's going to be using this system. You show them the explanation. You see, do they feel like they understand better? Do they get better at the tasks they're supposed to be doing? And you study that empirically. Obviously, that's the, does it work in practice? That's the gold standard. It's also quite expensive to run user studies. And in particular, if, as a developer, it's not really easy to do early in the pipeline, right? That's something you're doing right at the application stage, trying to sort of get regular feedback on whether you're making progress. If you're a technical researcher just trying to develop the general methods, those are not very easy to use. Then there are a number of computational metrics, many of them, but for instance, people often talk about robustness, which again can be operationalized in different ways, but one way is if you have a given input, you want to explain the output, then you try to vary the input a little bit, and so see the output should also vary a little bit, and the explanation for the output should also only vary a little bit. It seems weird if almost similar inputs and outputs generate very different explanations. So that's something you can implement computationally and check. People also try to do faithfulness. To what extent does it represent the model? Does your explanatory model predict the same things as the model you're trying to explain, and so on. And I won't go into these details here, but these are all these methods. Now, these are practically applicable methods, and that's the kind of stuff computer scientists will cite in their papers. But the problem is they don't have a strong theoretical grounding. It's basically based on people thinking, this seems reasonable, this seems like the kind of stuff we want explanations to be like. So there's still a lot of uncertainty and disagreement about these metrics. And they're also hard to generalize. Again, if you don't have the theoretical grounding, it's hard to know, okay, we did an experiment here, it seemed to get nice metrics. Does that mean it will work well in a completely different application context? It's very hard to reason about if you don't have an underlying theoretical grounding. So as a philosopher, I'm thinking, yes, I know what ethics is. I know what explanations are. We have lots of theory in philosophy about what good explanations are and what the good ethical principles are, frameworks. And myself and others have been doing work trying to apply these to explainable AI. But the problem is that we haven't gotten that far yet. And in particular, the kinds of frameworks and theories of explanation that we've been producing, and again, I include myself very much here, first of all, they're quite abstract, so they're quite far removed from sort of real-life implementations. They usually give sort of a high-level framework that says, oh, there are, you need to think about what the stakeholders will find explainable, okay? It's probably true, but maybe you could say a bit more. So that's one problem. And related to that, it doesn't give sort of very strict practical guidance. It still hasn't been developed in enough detail that you can really say, if Ira comes to me and says, oh, I've done this experiment, have I provided good evidence that I have an improved explainability method? The kind of theory I have available from philosophy doesn't give me a lot of guidance for that. It usually is sort of very high-level things you can show here. And this is really what we want to do. In our project, we want to try and bridge that gap between those two approaches. So try and get something where, has better theoretical grounding than current metrics in computer science, but is also a lot more practically applicable than what we have currently in the philosophy literature. This is work to be done, so I can't show you any results yet, but I'll show you a little bit about how we plan to do this. One thing, and this is the figure we use for the grant application. We're trying to explain how we're going to work together in practice. And we spent a lot of, actually, most of our writing of the application was thinking about how to explain this. And we came up with the idea of a feedback loop. It's sort of modeled on sort of quite common iterative design processes that computer scientists would be familiar with, and then thinking about how we sort of bolt on a philosophy component. So it's, I think, relatively intuitive. You start with step one. We come together as a research project, define some kind of use case that we want to study, maybe a specific method, maybe a particular experiment they want to run. Then we sort of split up. They think about how to do that in practice. We think about what are our sort of initial ideas about how to evaluate that. Then we do some feedback in step 3, try to align our expectations. In the computer science side, they will then run the experiment, do the empirical evaluation. In philosophy, we do what's called philosophical explication, which I'll tell you what that is in a second. And then we meet, analyze the results, and then we try to use that to inform the next step. And we're expecting to be able to run one sort of iteration of this loop in 4 to 5 months. So we hope in the two years to have 4 iterations at least. We'll see if that's realistic, but that's the hypothesis that we'll be working with. Okay, so I promised you I would tell you what philosophical explication is. A framework that I'm interested in using is one that's been developed in another context by Nancy Cartwright. So this is a theory of evidence, and Cartwright developed it because she was interested in evidence-based policy, interested in analyzing what people meant when they said there's good evidence that this policy will work. And so she developed this framework. The framework is pretty simple. It just says you have good evidence for some hypothesis relative to an argument, and you have it only if and only if the evidence is a non-redundant premise in that argument, so the argument wouldn't work if the premise wasn't there, and the argument is a good argument for the hypothesis you want to support. And ideally, you want a good argument to be what's called sound. So that means deductively valid. If the premises are true, the conclusion must be true as well. And you want the premises to be true. So in the ideal case, evidence in this sense gives you a proof that the hypothesis is true. This has a couple of interesting features. It's quite rigorous, firstly just because it's really, really demanding. It's basically a theory of what does it mean to have conclusive evidence. Evidence that just clinches something. But related to that, it's also really rigorous because it requires you to be explicit. You actually have to spell out the argument. And you have to show me what is your argument that your premises are true, and so on. And that's really useful because it allows you to make explicit a lot of the stuff that's often implicit when people make claims about evidence. So here's how it looks when Cartwright has been using that in evidence-based policy. I'll just give you a very short version here. Some of the earlier work. So you have these claims. There's good evidence for this policy. Sorry, should we say this policy is based on good evidence? Or there's good evidence that the policy will work. And in this context, people usually mean a randomized control trial. So you implement the policy somewhere with a control group, and then you see the community that gets the intervention, do they have better outcomes than the community that, or the individuals who don't get the intervention, and you try to randomize. And then ideally, if everything goes well and you've randomized and blinded everything correctly, then you can prove that the policy worked. And so it's really gold standard evidence. And Cartwright's question was, well, okay, what exactly is the hypothesis you're trying to prove here, right? What you can show is that the intervention works somewhere. So that's what you can prove with an RCT argument. And she analyzes the argument and shows you, yep, in the ideal case, an RCT is really strong evidence that the intervention works somewhere. But the problem is that in most cases, what you want to say is not, it works somewhere. You want to say, it's going to work here in the new place that I want to use the policy. I've tested, medicine is the same standard. That's where this RCTs come from, right? I've tested the pill on men, and now I'm going to give it to women. And I want to figure out, will it also work for women? And the problem with an RCT, it doesn't tell you anything about that, or very, very little. An RCT tells you that it works in the people that you studied it on, so it can work for some people, but it doesn't really give you any information about will it work for people who are different. And so a lot of her work was trying to spell out what kinds of arguments can you give to support that second step. And she's been very critical of policymakers, sort of making claims that their policy was evidence-based without having any good analysis of that. So here's an example where she works one proposal for how you could argue this. So you make some premises, and then the next step in the analysis is then to ask, okay, what kind of evidence could you have that these supporting premises are true as well? And so you unfold that and try to get the whole network of inferences as far as you can go. So that's the methodology I hope to be using for XAI evaluation. I want to sort of see there being two tasks. One of them is to try to define some more precise hypotheses when people claim that there's good evidence that this is a good explanation. That's often very vague. That's one of the things I want to be working on, just trying to make more precise what is an ethically meaningful thing that you could be trying to prove here, based on existing philosophical ethical theory, but also based on what people actually are trying to do in the experiments. And then once we've defined some good candidate hypotheses, then try to work out how can you reconstruct, philosophically explicate those inference chains that actually support the claim that people are saying. So that's the Remix project. As I said, it's upcoming, so I don't have any results yet, but that's what I'm planning to do. I also wanted to just show you one other thing, because I'm really proud of it. So this is another project, or another collaboration, and it sort of came about sort of adjacent to the one with IRA. So this time it's with some people in HCI, so human-computer interaction, people studying design and how people interact with computer technology. So about the same time that I joined Aarhus, Ira and Marianne Graus-Pedersen, they were applying for some funding, and they said, "Oh, Rune, do you want to be named as a collaborator, as somebody at Aarhus we can collaborate with?" And I said, "Yeah, sure." I put on the yes hat and said, "What harm can that do?" And then, they got the money, great, and maybe about a year later, some master students and Luke, who's a PhD student with Marianne, sent me an email saying, "Hey, you were named as a collaborator, can we come and talk to you?" I said, "Yes, of course you can." So they came and they talked to me about the work I've been doing in philosophy of AI, and XAI, and AI ethics. And then they went away and did some really interesting work on AI literacy. So they've been out in classrooms studying how to teach upper secondary students about machine learning. They've also done some really interesting work on XAI in journalism and LLMs. So you should look them up and look at that work, because it's really, really interesting. But what happened after that was done, then Luke said, "Actually, some of the stuff you were telling us about, that like your framework in one of your papers, I really liked it. I thought it was really, really helpful. Why don't we write a paper together, trying to explain what we got out of it?" So that's what we did, and it got accepted to FACT, which is a really nice conference in AI ethics. So I'll just show you very briefly what I got out of this, because this is actually a case where I learned a ton. They got something out of it too, but I got the most out of it. Okay, so in some previous work, I have this theory called explanatory pragmatism. It's quite close in spirit to what I told you before. The idea is that it's trying to define as one of these high-level, very abstract frameworks, right? It's saying that some P, some phenomenon that you're interested in, it's explainable by somebody to an audience in a context to the extent that the explainer can convey information to the audience that makes the audience able to draw inferences that are in some sense salient, important in that context. Sort of quite an abstract framework, but I think it helps resolve some things. They liked this framework, they thought it spoke to the work they're doing, but they also felt that there were some limitations or some constraints in the framework, and that's what we tried to spell out in the paper. And in particular, these are things that emerge especially when you do AI literacy work, although I think that applies to explainable AI in general. So I should say also, maybe just as a background, right? So this kind of framework, context-sensitive stakeholders, values, I'm not the only one who has a framework like this. Many people have said similar things, so I was just one of the people. But when you study AI literacy in the classroom, some things start becoming evident. One of them is that there are many different explainers in a classroom. So in the standard explainable AI setup, you're thinking of one user and an XAI tool giving them some kind of picture. And then you'd think, oh, is that picture a good explanation for this user? So the picture is the explainer and the user is the audience. In a classroom, you have many different explainers. Yes, you have some XAI tools and some other things that were implemented in the platform that we're using to teach, but there's also the teacher, there are textbooks, there are other, all the other students, and once we start thinking about this, we all have mobile phones and the internet, and there are all these different sources of explanation. So it's a very simplified model just to have one explainer. It's also not one-off. Learning isn't just like here's the explanation. Learning is weeks, months, years for some things, where we build up gradually us understand things better and better, integrated with the other things we understand or want to understand. Also, it's not just information transfer. Like, a lot of learning is not about sort of spoon-feeding information to your students. It's about giving your students the information so they can discover more for themselves. Sometimes you talk about they construct their own understanding. You don't spoon-feed it to them. And finally, this idea about the context, with a nice little C as the context. It's very simplified, because there's always many contexts. A classroom isn't just a classroom. It's also a place where people go when they're not going to football. It's a place where people go, before they go home, and they've been, it's also a place where people go to meet their friends and maybe not be too bored, and so on. They're also not just one audience. There are many different stakeholders that have many different kinds of values, and so on. So there's a lot of complexity there that's not captured by that simple model. The solution was to use something called activity theory. Don't know if anybody here has heard of it. It's a framework that's very popular, particularly in participatory design. I think I won't sort of explain the details, but the idea is very much to say, when you're interacting with an object, it's always mediated by tools. So that's one shift. Don't think of it as explanations. Think of it as explanatory tools. It always emphasizes context. So the C refers to community. The D refers to the distribution of labor within a community. The R refers to the rules that people follow in that community. That's always part of the analysis. So in the paper, we're trying to use this framework to give some more rounded, interesting, fleshed out analyses of all the different kinds of interactions that goes on in AI literacy, but we think this generalizes to XAI in general. And it's forthcoming, so go and check it out if you want to see the details. We list a lot of different changes to what I wrote back in 2020, and then it was published in 2022, right? And again, I won't go through it, but it sort of emphasizes its tools. It's not just this context, it's multiple stakeholders. Okay, so just to wrap up, right, the conclusions here. How can philosophy and computer science interact? I think there's something about philosophical theory that helps us make assumptions explicit. So lots of science is done by people, experts know how to do things. So a lot of things is implicit in scientific practice. Philosophers, we like to argue and we like to things to be clear, so we are good at making things explicit. I think we can learn a lot by studying how XAI is done in practice. I think that will create better philosophical theory. And both of them require sustained collaborations and engagements. And as I tried to highlight also, these collaborations, they take, before we even got the project started, it's been 3 years now, right? So it sort of builds up over time, and it's often through teaching and our students that this comes about. And that's really all I wanted to say. Thank you very much for your attention, to my collaborators and my wonderful funders. Thank you.
Thank you so much. We have time for some questions. So there is one there at least.
Thank you for this very nice talk. I'm always very happy to see feedback loops implemented everywhere.
Yeah.
So over the past few years, there have been a lot of conversations in the media about AI and so on. In the 80s, there have been conversations in the media about AI and so on. So the word AI, right, it kind of changes meaning. It kind of changes how people understand it. And at some point, I came across this perspective from a person who was from a marginalized community. This person was responding to an explanation, right? Let's call it. Well, actually, AI is so much more than LLMs. It is this and this and this and this and this. And the person who was this vulnerable representative of a vulnerable community said, well, I don't really care how you call it. I care that the way I call it affects my life. So now, my question is there any of this in the explainability? Because, okay, the terminology, we can talk about it forever, but what about the explainability? What are we trying to explain? Does it get understood the same way, or is there some sort of pushback that, no, I don't want to understand it like that. I want to understand it through my own cognitive or mental models and so on.
It's a really interesting, really good question. So in the technical explainable AI literature, it's usually just done in a computer science lab. So computer science people talk to each other and do things with code. The more user studies focused bit, which is more where Marianne, the second collaboration, where she works, talking to people, figuring out what they value is very implemented there. But there's still lots of negotiation, right, about it. Many things have been called AI. I think pocket calculators count as AI, in my opinion, for historical reasons. And I guess at the end of the day, that's like, this is again why I really value the AI literacy perspective, like the pedagogy. There's actually a field that has a lot of experience, also mistakes, but also experience with like, how do you explain very technical things? Everybody learns about thermodynamics these days. That used to be cutting edge science, some of the most complicated abstract thing you could possibly study. And now it's something we teach to, I don't know, 14-year-olds maybe. So we've learned how to explain very complicated things before, and I'm modestly optimistic with lots of caveats that we can do similar things, but it takes work for sure.
Yeah, yes, there is one question there at the back.
Hi. Yeah, so I was going through all the lectures, and I had this question from very beginning, like when you decide this framework over deciding how AI should respond. So when you try to have this ethical and all aspect of philosophical aspect, even into there you have so many segments. AI should be trustworthy, it should be ethical, it should respect privacy, it should be reliable. So when you make these kind of tool for it to align with it, how you rank them? Like what you want the AI to be most? Do you want it to be more trustworthy, more reliable, more privacy?
Yeah. I think I get your question. I think it sort of also came up in the last talk a little bit, right? It's a really hard question. I've also written about how a lot of these values can mean so many different, well, a lot of these words that we use to express our values can mean so many different things. So even if you just say fairness, people have very different conceptions about what is fair in practice. And I think that's really, really hard. I think it's really interesting, the kind of risk assessment work, how to manage that. So I guess in this kind of work, I'm trying to take a different approach where try to make something that's more bottom-up, that's focused on something very narrow. Like, can we just make one claim that it would be, if we have evidence that this explanation does this, and hopefully we'll find something that's broadly consensus that would be a good thing. Can we even provide evidence of that?
Yeah. But
so that's the strategy I'm pursuing here. One question is sort of very high level. How do we rank all of them? How do we define fairness? That's sort of a top-down approach. And I guess my strategy here, which I think is complementary, is to try something more bottom-up. But yeah, you have a follow-up, sorry.
Yeah, so because this question, it has came up from, for example, even in judiciary, they have like, if a conflicts come, then the fundamental right will prevail over something else. So if you, while making a policy or something, if two things clash each other, which will prevail according to you? Like, what do you think should go?
Yeah, I mean, in general, this question has no answer, right? That's just how it is with values. There's no, we don't have ethics pocket calculators. They don't exist, and they never will. What we can do is, of course, when you make a claim, right? So if I write a paper and I say, I think we can get evidence for this hypothesis, and I think it would be, which is an ethically valuable hypothesis, I'm obviously making an ethical claim. Someone might challenge me. And I think that's just part of how we solve these things in practice. I think ethics, very broadly speaking, is a conversation about how to live with each other. So I need to make explicit what things I'm taking for granted, and I can try to justify it. I can give my reasons for why I think this is an ethically good decision. But I should also not pretend that this is like proof. And I should be ready for people to come and challenge me and say, Rune, you've completely ignored, this perspective. There's this group that you just haven't even talked to, and they think you're wrong. Okay, and then we'll have to take the conversation and figure out, do we disagree, and how? And I think that's just how we have to do it. I don't think there's an alternative to that.
Yeah, so basically feedback again here as well. Thank you.
Well, yeah, it's conversations all the way down.
Great. Thank you so much, Rune. Let's take him again. Right, so the next speaker is Jan. He's been here before, so he should know how to do this.
Yeah, thank you, Samia. So, all right. Yes. Yeah, so actually, my history of being a researcher is reversed from the previous speaker. I used to be a computer scientist, and now since 10 years, I work in a philosophy department, trying to think about AI and its ethical implications, and well, basically also what it can do and what it cannot do. That kind of questions I'm asking myself, and today I'm asking the question, do large language models mean what they say? Well, maybe you think, well, of course they don't mean what they say. So maybe this is not a really interesting question to begin with, but I will argue, well, that it is an interesting question and it is an important question. And actually there's many people around there, also philosophers, but also in computer science, who do not see any differences anymore between, let's say, what potentially a large language model could do and the kind of stuff that we do. So if this idea that large language models are so very competent in everything that we do and that they are becoming indistinguishable from our cognitive abilities, then suddenly this question, of course, becomes very interesting. And what I try to do is, in this talk, I will have 3 arguments why large language models cannot mean what they say, and they are linked to 3 different philosophers. The first philosopher is Hilary Putnam. The second philosopher is Michael Bretman, and the third philosopher is Elizabeth Anscombe. So that is a lot to cover in one talk, and I'm not sure whether I will manage to do this within half an hour. So it might be that I will eat your lunch, but please stop me when it's time. And maybe we can do the questions afterwards during the lunch or whenever you see me walking around. All right, how does this work? Probably like this. Yeah. So what are we asking exactly in the title of this talk? I ask, do large language models mean what they say? Well, what does meaning what you say mean? Is that the same as not lying? Sometimes that is being used for not lying, so he doesn't mean what he says, he's actually lying. No, that's not what I mean. So actually, when you lie, you actually mean to lie. So you mean what you say by lying. So that is not the kind of thing that I'm after. I'm not interested in lying here. It's related, but it's not exactly what I mean. Meaning what you say is maybe the sender utters a meaningful, is being meaningful or something like that. Well, that's also not exactly what I mean. I mean, it is of course, if you mean what you say, then what you try to say needs to be meaningful for the receiver in order to assess what you say. But that is not exactly what I mean. What I mean is, meaning what you say is intending to convey a certain message and choosing the language that supports that goal. That's what I want to. This word intending is very central here. What I'm going to argue about is just all the arguments that I have are about intentions. And I will just basically argue that large language models do not have intentions like we have. Okay, first, well, why is that an important question? Why am I so focused on intentions? Why are intentions important? And why is it important to think about whether large language models really have intentions or not? Well, I think the first reason is alignment. This the theme of this workshop. I think the most important thing when it comes to alignment between humans and AI is that they want the same stuff, that they have the same intentions. That's also when we are aligned to certain people. If we really trust people, people can make mistakes. People can do, and then we forgive them maybe the mistakes. But what is most important is that what I intend to do is aligned with what somebody else intends to do. And if that kind of alignment is there, then we can trust the thing. So for alignment, it's a very interesting question. And actually what I'm then arguing here, if AI cannot have intentions, then there's nothing to align with to begin with. Not in this sense, not on this level of intentions. You cannot make an alignment because the AI does not have intentions. Okay, so that's why it's important. Another is, and that links to the previous speaker, explainability. One way of explaining systems, their behavior, etc., is in terms of what they intend to do. And this is also a common way to explain AI. So it does that because it intended to do that, or it wanted to do that. We do that all the time, of course. I talk in these words about my own computer, about the AIs that I use. But of course, I know that it is just a way of speaking. And I think it is important to just assess whether that way of speaking about explanations, intentional explanations, actually has some merit to it, is actually truthful or not. I think that is the answer to that question that matters. Okay, so that's why it's important. And here is a recent paper by Emma Borg, 2025, Turing Tests and Chinese Rooms, the prospects for meaning in large language models. And she asks basically the same question. As part of this paper, she also asks, do large language models mean what they say? She says large language model outputs are meaningful in a derived way. So the text that they produce, they are produced by the large language model, that's clear, and the meaning that is in those texts is in some kind derived. We understand what they say, but what does it derive from? That's of course the question. Where does this derived intentionality that is in the text, where does it exactly derive from? Does it derive from something that is in the large language model? Or does it derive from all the text that it's been trained on, and implicitly it derives maybe from us? So that's the kind of things she deals with. She also explains large language model states do not have original intentionality. That is a term by John Searle. And the idea is basically only we humans, we have original intentionality, that our mental states, they are not derived from anything else. They are just our mental states, and they are the source for, let's say, derived intentionality of text. So if a text is being written and it means something, that is because there was an author behind it that had original intentionality and that meant to say something with that text. And then the question is the same true for large language models? Do they mean to say something? Well, Borg says that large language models do not mean what they say because they cannot make true assertions. And I don't agree with that, actually. I think it's something else. So she thinks that there is no intentionality, there's no source for the intentions inside the large language models because what they say is possibly wrong, or there is no evidence to connect to the previous talk about what they say, if that is true, or they have no idea themselves whether what they say is true. So she thinks that the reason that they don't mean what they say, that has something to do with the truth of the things that they are saying. And I disagree there. I think that is not the right analysis or not the right reason for claiming that they don't mean what they say. I think it's more basic than that. They simply don't have any intentions to begin with. And I will put forward 3 arguments for that. Okay. So let's just skip this. So this is the overview of the talk. My mouth is getting dry already. Okay, so what kind of systems can have intentions? We know that we have intentions. We can intend stuff. We can, and on the basis of what we intend, we act, we do stuff. So I'll say a few words about that. Then I will give the 3 arguments. And maybe I will run through them a little bit quickly because otherwise, well, the time is limited. The first is a production-oriented argument against intentional conversational agency for large language models. The second is a consistency-based argument against large language models having intentions. And the third is a direction of fit-based argument against large language models having intentions. Okay, let's go to the first one. Right, I'll also skip this one. Yeah, okay, so this is a picture that sketches basically how human intention plays a role in the text that we write and the text by which we have conversations with each other. So here you see a human. Here is a human. This human has original intentionality, so his mental states are original. He really intends stuff, and on the basis of that he writes text. Those texts are interpreted by another human, and that human, because he has this same original intentionality, he probably understands what this person is he means to say by writing that text. So he interprets that, and here it is quite clear that the texts are used to express what the people conversing with each other mean to say to each other. That's the idea, because there is original intentionality in both. But what if one of the two is now ChatGPT or a large language model? And here we still have this human with original intentionality, meaning to say stuff by coming forward with certain text. Maybe these are the prompts that are being inserted to the large language model. Then the large language model comes back, and the question is, does the large language model mean to say anything by the text that it is producing? Is there also intentionality inside here? That's the question. Okay. First argument that this is not the case, and it is based on an idea by Hilary Putnam about random generators. Here you see, again, the human producing text, and assume that there is just a random generator. A random generator producing texts. Well, most of these texts will be, well, complete nonsense because they are randomly generated, and they mean nothing. So that is also Putnam's central argument. He uses this in a certain context of the philosophy of language, but a random generator is obviously not an intentional agent. It cannot be that something that is produced randomly is intentional. If a system is a random generator, then it cannot be an intentional system, can it? I mean, that is, of course, first that we need to believe before believing this argument. But this random generator in the previous picture miraculously produces the following text. This sentence is just a random sequence of symbols. That is true. We can interpret this and we see, right. And then you wonder, okay, if a random generator could imprint, and of course it can, because it just can produce everything, and by coincidence it might produce a sentence that we can interpret as maybe being true. Well, if it is true, it has meaning. If it has meaning, maybe, and it is produced by a system, maybe then the system meant to say that certain thing. Otherwise, how can it otherwise be true or have meaning, etc.? So there is a kind of derived intentionality in this sentence, but what does it derive from? It cannot derive from coincidence, that's impossible. Well, so Putnam uses this kind of examples to say assigning meaning must be a mistake. So there's no intention, it's not the right causal history behind this because there was a random generator. And it is quite obvious that this cannot be, that this random generator did not meant to say this thing because it is a random generator. So it really matters how something is produced. to assess whether certain is being said intentionally or being produced intentionally, it matters. You have to look at the process of how it got there, and the specifics of that process, they do matter. And they need to be of a certain kind. There needs to be the right causal production mechanism in relation to certain mental states or certain. There needs to be something. It cannot be randomly generated. That's the point. So the lesson one is machines need to mean what they say to produce meaningful text. Yeah. Right. Lesson two is how a system produces its output determines if it means what it says. Okay, then you say, wait a minute, this might sound like an argument that large language models, who are also based on statistics, and maybe there's a little bit of randomness in there, yeah, they cannot be intentional, but large language models are not random generators. They have a certain systematicity to it. They systematically produce sentences that we interpret as meaningful. That is simply true, isn't it? We interact with them all the time. So you could have as an objection here, wait a minute, a random generator only produces interpretable texts really very rarely. So sometimes it produces gibberish, like with the hallucinations, but systematically they produce the right kind of text. So is this argument about random generation, does that hold any ground? Is that a valuable argument? Well, we can look a little bit further about how large language models systematically produce their outputs. We all know by now, previously 2 years ago when I was here, I explained this a little bit in more detail. Now I will skip this and go much quicker. Large language models like ChatGPT, they predict words. What they do is they make predictions, they predict the next word. So if you give it a prompt, they look at the symbol sequence, and they've seen so many texts with certain symbol sequence, and then they predict what is to come next, and that prediction is actually their answer to your prompt. Okay, nowadays we have a little bit more sophisticated stuff like agentic AI. Maybe at the end I will reach the point where I can explain that a little bit, but this is the basis. And this is the basis of how it works. To predict those words, deep learning is used. That could have been something else, actually. You could also have, okay, this is maybe not so important for this talk, but deep learning, and I will also not explain how deep learning works exactly. What would be good is actually this is something, usually I have control over my own presentations, but is it possible to open that link? And then we will see a picture of a transformer. No? Can we click on that link? Apparently not. Well, if it's not possible, okay, it's not possible. I see somebody shaking his head in the back of the room. Okay, so, well, this is actually a very good animation of how large language models work. I recommend, so it's called the Transformer Explainer. The Transformer Explainer shows you the neural network, actually, that works on a prompt, on the beginning of a sentence, and then you see how it goes through the neural network, and that the neural network has certain specific aspects like transformer heads, etc. And well, if you know all this stuff, then there goes a lot of thinking in how to structure those neural nets. And those specific neural nets used for large language models, they are called transformers. But in the end, the only thing that is happening is just, okay, you have tokens. The tokens are being decoded into zeros and ones. The zeros and ones go into the neural net, and the neural net predicts what should come out, and what comes out is just the next word or the next tokens. And then, okay, there's of course a little bit more to it than this, but this is the principle. Right. what is interesting in that animation that is on that web page is that you can play around with it, you can sell, but what you can also see that if you have a sentence that is not finished, then it will try to finish that sentence with words that fit what came before, but with a certain chance. And actually in the beginning, when in 2022, when large language models came onto the market and were developed, there was no temperature coefficient, and they simply took the word that was the most likely to continue the sentence until then. And what happened then was that the interactions became very boring. And the large language model basically reacted in the same way every time to what you said. It used the same kind of constructions and idiomatically, etc. So what they thought is we need to randomize it a little bit. So they take, let's say, so the prediction what the next word is maybe like you see 10 different words, and then you take a certain window and you say, okay, I randomize between the first 5. So what is being said in large language models is actually a matter of randomness. So, and then, of course, then Putnam's argument that it matters how something is produced in order to be able to assign meaning to a sentence suddenly becomes very relevant, because if indeed part of it is just because it is randomly selected, then how can we actually say that this sentence is intentionally produced by the large language model to say a certain thing? Okay, that's basically the first argument related to Putnam's views on, or one of Putnam's examples in the philosophy of language about how something is produced matters for assigning it meaning. And if it is random, then it seems very strange to argue that it means what it says. It doesn't mean what it says, it randomly selects what it says to a certain extent. Okay, so that's just the first argument. Let's go to the second argument. How much time have I left, Samia? 8 minutes, okay, it's a countdown clock. Good. Okay, that's possible. Let's go to the second argument. The last argument is actually the most interesting. Maybe I go through this one a little bit quickly and then see if I can reach the final argument. Here you see a picture. Actually, I made this picture using AI. So since I'm from a technical background, I work in LaTeX. And if you have a certain picture in your mind and you describe the picture to the AI and you say, make a LaTeX picture of it, then it makes it. And then it adjusts it and it does all kinds of tricks that I was not even aware you could do in LaTeX. But anyway, so this is being produced by an AI on the basis of me prompting it to make a certain picture. What do you see here? You see one agent, you see another agent, and you see here an agent, and this is the large language model. Yeah, maybe you don't see it, but these eyes, these are for intentions. These patterns on top, they are like the output. If we write a text, then we output signs, characters on paper. So they have a certain pattern, they have a certain order. You could look at these arrows in different directions as a kind of pattern that we produce, a kind of text maybe. And we do that intentionally. When we write a text, we intentionally write those specific characters and not others, because we want to convey a certain message. We have a certain intention. We want to convey a certain message. This other author wants to convey another message, and that gives you another pattern. And this author has yet another intention behind his text. And that is all the text that the large language models are being trained on in the internet. Every text out there, well, maybe by now not every text anymore, because lots of texts are produced by AI. But all human-produced texts, they had an intention behind it. These authors wanted to say something. What the large language model does then is take all these patterns somehow recombine that pattern into a new pattern, and that gives you that pattern, and that pattern is then the answers that you get from the large language model. And then the question is, does that pattern also represent an intention of the large language model? Does the large language model have an intention just by taking somehow of recombination of all the patterns that were the result of the intentions of the individual authors? Is it then the right to say that you get an intention also here? And I would say no. Well, I just gave one argument and now I have another argument. And this argument is based on Bretman's theory about intentions, because Bretman says intentions need to be consistent. Consistency is one of the main characteristics of intentions. Well, this author probably produced something that was consistent, given what he intended to say. This author probably produced a text that was consistent. Maybe it was logically consistent. Maybe it described a certain technical device that would not collapse or something like that, or would not run into problems. So there's all kinds of measures of consistency. But the kind of content that this author wants to produce needs to be consistent if he means to say something with that text. For all these authors, that is the case. And then you get this procedure, the large language model, just the pattern taking some kind of average. Average is not the right word, but you understand what they do. It predicts the next word based on all the text it's seen, and it doesn't look at inside what the pattern means. It just tries to continue patterns. And that's what the large language model does by predicting the next word. That's what's happening with all the dotted lines, and then you get a new thing. Then the question is that new pattern also consistent in the sense that it can link to an intention of this large language model? And I argue no, because there are examples where this is consistent, and this is consistent, and this is not consistent. Take, for instance, the example of a chess playing a large language model. This author is maybe also a chess player, this is maybe a chess player, and this is maybe a chess player, and maybe these are the moves, the patterns are the moves on a chessboard. And these patterns are also the moves on a chessboard. And if a chess player aims to play a certain strategy, that strategy needs to be consistent. Otherwise, it cannot win against the opponent. So strategies need to be consistent. Sometimes they are not, because then the player is making a mistake or something like that. But you could see that maybe here there is a chess strategy pattern, here there is a stress strategy pattern. The large language model is being trained on all the chess books out there and all the chess games out there. And it takes a certain, it recombines that into maybe a new strategy. And we know what happens, but that new strategy then needs to be consistent in order to say that that strategy is an intention of the large language model. But we know how it happens. Not anymore. And we can go into that in the questions if there's time for that. But we know what happens if you play chess with the large language models. It seems to play very well. It has an ELO rating of maybe 1600, 1700. That was 1 year ago. And then suddenly it plays an inconsistent move, let's say, or it plays a move that is against the rules of chess. Not consistent. It does not behave consistently, even though it knows all the rules of chess, because if you ask it about it, then it will produce all the rules of chess, but it will not play according to the rules of chess. And that's because of this mechanism of dotted lines is not interpreting strategies. No, it is recombining it. And it's taking consistent patterns and it's recombining it into something that is not necessarily consistent. So that's why it cannot be an intention of this large language model to play the strategies that it plays when it's playing chess with you. It's no strategy, there's no intentions behind it. It is just recombination of things that it saw, knowledge that it has about the game, but it is not intending to win. Okay, that was the second argument. Now I have 1 minute left for the last argument. Let's see. A direction of fit-based argument against large language models having intention. So this is the third argument, arguing for, again, the same thing, that there cannot be intentions driving the behavior of large language models. And I need to explain something, and that is about the direction of fit. The direction of fit is a term by the philosopher Elizabeth Anscombe, and it is about the difference between knowledge and intentions. Knowledge have a certain direction of fit. So knowledge expressed as a kind of propositions, things that can be true or false about the world, they have a proposition to world direction of fit. So a proposition, if it is true, that means that it has to fit how things are out there. And there's things out there in the world, and the proposition tries to describe that, and it is true if it fits how things are in the world. And so the direction of fit is from the proposition to the world. With intentions, it's the other way around. So intention, it actually should not be the case that the proposition that expresses a certain intention is true in the world, because if it's already true, why would you even intend it? And the point with intentions is that you aim to make the world such that it is coherent with the proposition that you intend to make true. So the direction of fit between propositions, between knowledge and intentions is the opposite. They have the opposite direction of fit when it comes to propositions and how they relate to the world and things being true or false in it. Okay, so that's very important. Knowledge and intention have an opposite direction of fit. And my claim here, and that's the third argument, I see I'm already ran out of time, and after it I only take one slide more, and then we can go to lunch. The mechanism of statistical aggregation does not match with a world-to-proposition direction of fit. So also relating to that picture that I just drew, that is based on, well, let's see what the patterns of the individual authors are and try to make a new pattern. And so that direction of fit, trying to match patterns that are being produced by others, that is very much the direction of fit of knowledge. And you try to be correct in predicting the next word, and correct simply means what the other authors that wrote the text that you're training on thought was correct. And that direction of fit does not match with intention. And let's go through, this. Yeah, this is the last slide. You can ask, where is the mistake? That is also what Anscombe asked. So if a large language model makes a mistake, if we make a mistake, sometimes we have a certain intention and we make a mistake. And if we make the mistake, then we say, okay, I did not execute the intention very well. I did not execute the intention well, and that's what the mistake is. Because I have intentions, and I wanted to do this, and something else came out of it, and that's where the mistake was, in the execution of the intention. Well, is that also true for large language models? I don't think so. Actually, in large language models, the mistake, we actually treat it like that. We treat mistakes in large language models as mistakes in prediction. That is because large language models, that's what they basically do. They make predictions. They predict the next word, and if there is a mistake, we say, okay, we made the wrong prediction. We predicted the wrong word here, because in this context, it's not the right word to take. So there, the mistake in large language models, the mistake is never in the intention, because there cannot be intentions. The mistake is always in the prediction. And this relates to a very famous debate in philosophy about whether deliberation crowds out prediction. Anscombe would say, yes, if you are a deliberating, autonomous, free-willed agent, then your deliberation crowds out the prediction. You cannot predict what you will do yourself because you are a free agent. You cannot predict what you will do, to some extent, but there's something nonsensical about predicting what you do yourself if you yourself are the decider of what's going to happen, of what you're going to do. So you can have a prediction, but ultimately you can also choose to do something else. Maybe even the prediction means that you're not going to do what you predict you will do. You see that there is tension here between, let's say, agency of the autonomous kind, of the free will kind, and predicting, making predictions about yourself. Large language models being based completely on predictions, they can then not have intentions, because intentions only make sense if you are an agent of the kind that Enscomp advocates for. Sorry to have taken 4 minutes of the lunch, but I have to leave it at this. Thank you.
You went over time, but you have the entire lunch to actually take questions. So please talk to him while eating. And this is a small gift from Bergen. Thank you so much. All right. And now there is lunch until 12:45. after the lunch break. We start with the next talk, which is by Holli. So please welcome her. Good luck.
Good afternoon, everyone. Thank you so much, not only for actually coming back after lunch, even though I'm sure many people want to take a nap in the sun at this time today, but also thank you, of course, to Samia and Doug and everyone else who has helped organize today's workshop. I've really enjoyed the presentation so far, and it's really nice to be in a setting where we can talk about these sorts of issues from so many different disciplines. So I'm hoping today I can provide actually some context to the things that have already been asked in questions about how do ethics and law interact when we're talking about these technical design choices and what we mean when we're defining and designing AI systems to align with certain values. So, as Samia mentioned in my introduction, I'm now a research fellow in law at the University of Cambridge, but previously I was a solicitor and I worked in a lot of projects about data and tech. And at that time, we didn't have a lot of regulations, certainly not the amount of regulation that we have now to handle new AI systems. But it was a really interesting time when you're a lawyer in practice, you get asked a question and do the facts map to the law and can you apply them or not? And at the time, I felt really frustrated by those limitations because you often can't get into the interesting ethical questions about, well, the law is probably going to change and this is what the law says, but we actually don't agree with the outcomes of that. So what I really enjoy doing as an academic is being able to take what does the law currently say, how can we try and translate that in a more meaningful way to people from different disciplines, but also maybe the law does need to, in certain settings, update. But I'm also of the opinion that sometimes the law doesn't. Often the law is a much more flexible system than people give it credit. From the outside in, it just looks like a set of rules, but often it's actually a set of principles and values. So there is a lot more ethical alignment within the law than we necessarily give it credit. One of the things I wanted to do today is to narrow in. We've been talking a lot about broader ethics, values, principles. Often they're in tension, but to kind of get into the tension with law, I wanted to give a specific example where today I want to talk about equality. So in the technical literature, this often comes up as sort of bias and fairness. I'm not speaking generally about bias and fairness. I'm speaking very specifically about demographic-based bias and fairness in the differences between people with protected characteristics such that the law would care about. So this has been a big area of research within the technical field. There's some very good research as well, of course, from interdisciplinary, socio-technical, and legal scholars. But it's a really good way of exposing the tension between ethical, technical, as well as legal considerations. So the title of my talk is the Incompatibility, and what I wanted to focus on today is this incompatibility from the perspective of law to values, and specifically the way values have been encoded from the technical perspective. So a lot of current methods about designing fair algorithms is based on the assumption that we can encode these values through design. The idea being that fairness is both a computable constraint that we can use to constrain outputs in a fair way, but also that we can design fairer inputs and the systems themselves. Such that non-discrimination law, so I'm going to use these terms to try and separate what I'm saying. Non-discrimination, I'm talking about law. When I'm talking about fairness, I'm talking about the values. And the issue is that not only does computation fail to encode equality, it actually might succeed. It's just turning equality into something that's structurally different. So to encode equality in the way that it's often presented in technical literature, what we're trying to do is have a model that can define in mathematical terms. So you're defining input x's, and these might be protected variables. Let's just say gender, male and female in this very narrow sex-based discrimination setting from attaining data. We also have opportunities then that you might get encoded from different parts of the design process. So a common example is, let's take consumer finance settings. So banks are using a machine learning algorithm to predict who gets what loan payment terms and who gets granted a loan. What banks have done in the past, not naming any in particular, is they say, oh look, we have this huge historical bias where women have had worse outcomes in financial settings because they've had less opportunity to the credit market until recently. So what we'll do is we will course correct that, and we will make the threshold different for the predicted repayment value for men versus for women. So that's a way of encoding something that might look like fairness to overcome a historical bias in data. You might also then have an outcome-based metric or constraint where they say, okay, well, instead of defining it within the algorithmic setting, we're going to do it as a ex post constraint on the model and say, well, we have way more profitable terms for men than we do for women, so we're going to actually course correct at the end stage. So what's challenging about that is that that's a very narrow conception of what we think of when we're talking about equality, particularly from a legal perspective. So these technical approaches are not discovering the meaning of equality, they're actually defining their own meaning of equality in this particular setting. Now, what's particularly challenging is when we think about this from the legal perspective, sure, there is a rule that says you should not treat people differently on the basis of their sex. But that is not the whole law, and it's certainly not the whole system of principles and values that the law is actually trying to encode structurally, rather than encode in a specific technical way. So this is where I think the translation from law to technical metrics fails. The incompatibility forces a choice. So it's forcing a choice to say, well, we want to see either equal outcomes of men versus women, which is very different from the choice to say, well, we're just going to treat men and women the same in this setting. Or instead of saying, actually, we want to reflect accurate predictions, even if that means that we do have a disparity on the basis of a demographic group. One of the challenges with that too is that prediction works through proxies, as we all know. So it's a very different way of decision-making than a traditional setting where your average person walked into a bank, probably spoke to a person that they knew, and put in paper-based forms and applications that might have been a bit more of a vibes-based decision-making that we had before it became this huge exercise in actuarial sciences and aggregate data. And that's a very challenging mapping exercise when the law was designed for that historical version of decision-making. It was meant to protect people in these specific cases about a person is making a decision about you, and usually you could identify that very clearly just from their personal prejudice. It was also easier to prove in court, and I'll come back to that, because it was very different where you could walk into a bank, someone said a racist slur, and all of a sudden you have a case and you also have physical evidence that you can point to of a differential treatment because of something that was said or written down or could be shown. Now we're looking at patterns that are really hard to identify across, let's say, national, international banking systems. But of course, I'm picking out banks as an example, but this goes across lots of settings. For example, if all employers across Europe start using the same AI tools to make predictions, it's going to be really hard for an individual person to identify that HR person said something to me discriminatory in an interview versus we've identified a systematic type of discrimination across the model in all of these different settings. And so this is one of the sort of additional challenges, is that this statistical classification, profitable, not profitable, hireable, not hireable, good, bad employee, it's not a form of legal adjudication. The reasoning on these group level probabilities is not a prediction of, will you specifically be a good person for the output that I'm predicting? Are you likely to repay your home loan? This type of modelling is now saying, are you like the group of people that repay their home loans on time? And removing the individual aspect of decision-making, I think, is a significant challenge for the legal system. And this is where these tensions start to arrive, that trying to map these principles that were based on this system, this individualistic-based decision-making system, is not perfect to map to this group-level aggregate statistical classification. And so where does this translation fail from the more legal perspective? So this is where I think it's very interesting that often we're talking about fairness and equality in machine learning as a tension with accuracy. So we say, for the most part, lots of these papers have said, well, the most accurate model is going to have differentiation between people based on protected classifications and characteristics. Now that, of course, should be no surprise because everyone is different. It's not an inherent difference based on a protected attribute. It's just that you are going to see a huge amount of variation. And if you're doing this in an aggregate statistical setting, you're also going to get to a point where you might be able to spot statistically significant differences in those patterns. The law doesn't say, was the decision to hire you correct? It doesn't ask, was the decision to hire you fair? It's asking, did a person directly or indirectly treat you differently based on a protected characteristic? or by association to a protected characteristic. So you see how these questions just do not map as organically as we might think that they do. They're also just a completely different way of thinking. So often I find that my research ends up being a translation exercise. Law is really weird, and the terms that we might use to mean something are not necessarily the terms that people in other disciplines use. Philosophers will find this, technical scholars will find this. What I mean by causation is in no way what a statistician means by causation. When we're doing these comparisons about accuracy and classification, we need to use different sets of language and understand that they just mean something different. So machine learning systems, optimizing for predictive performance, having this trade-off between fairness and accuracy and saying, well, it's not the most accurate system, but don't worry, we've got gender equality on the back end, is not quite what the law is interested in. And one of the things that's sort of coming back to is, of course, equality law has this rule. Actually, most laws, they have the rule. Then they have 100 exceptions to the rule, and then they have the procedural aspect of proving whether that rule was broken or not. And so often in the translation exercise of saying, well, is this a discriminatory algorithm? We're just asking that first question. Did it treat someone differently, directly or indirectly, on the basis of a protected characteristic? But I'm also quite interested, and the reason that I use the example of banking is that banks have a huge number of exceptions to that rule, because it's actually not fair for a person to be granted a home loan if they shouldn't have one. So saying, oh, but we did a great thing and we gave more women home loans. Well, what if all of those women default on their home loans because you actually haven't done accurate and actuarial decision-making? There's unfairness in both directions. It's the same across lots of different areas of high-risk decision-making. The same thing is true in the criminal justice system. There's different thresholds and exceptions for whether or not it's a good or a bad thing to receive a certain outcome. It entirely depends on the context of that setting. The other thing is important is that often focuses on not just these sort of stipulated excuses or exceptions to the rule, but also a justification, because we all need access to credit, but the credit system entirely fails if banks aren't able to actually get returns on their loans. So the structure of the mortgage or consumer finance system also depends on people actually repaying the loans, otherwise the financial markets themselves will collapse. So there is this broader social justification that the law has to operate within. It's also important that we're protecting rights that are not reducible to these optimizations and particularly not to trade-offs. And I think that's one of the real challenges that we get to. I mean, we've talked about this a couple of questions today. Ethically, lots of these values we see as important things that we have to protect. The law operates in a way that it has to put prioritization on certain values to the exception of others. And in this particular sense, the law doesn't say a most accurate model is important or not important, but what it does look at is it does look at whether or not one of these exceptions have been met. So I always get nervous with this slide with a few philosophers in the room, so I'm speaking in sweeping generalizations, but I do think this is a helpful analogy to make, which is that the logic of this algorithmic form of fairness and equality is generally pretty consequentialist, right? It's a focus on outcomes, it's not necessarily a focus on rules. It's treating discrimination as a measurable quantity to be minimized, where there are some trade-offs and exceptions that are fine. If overall this is an accurate and model that avoids discrimination for the most, a few people not having a good outcome is just inherently part of the system. That's part of just this idea of the parity across aggregate populations. Substantive equality law is resting more on a rights-based commitment that we could define as more deontological. It's actually not particularly interested in your optimization problem, and it's certainly not interested in your trade-offs. It's focused on a specific set of rights to say you have a right to non-discrimination, and that rule must be upheld. Part of that also comes into this justification. Proportionality is also not what most, let's say, computer science settings would take it to be. This is not a cost-benefit analysis. It's not that simple, and it is a huge weighing effect that the judges and courts give a lot of weight to different values and different impacts. They're looking at sort of the effect of harm on an individual person, harm on a societal level, as well as how important it is to keep that justification. For example, how important is it that banks are able to make accurate decision-making? How important is it that employers can actually hire the best person for the job? So this is from a paper that I've recently had accepted. I'd love to share if anyone would like to read a very long-winded legal article, but hopefully I can give you the cliff notes today. The idea of this article is I was looking at two sides of the coin. a lot of literature says it's going to be very challenging to prove algorithmic discrimination in courts. And in some ways it will be hard because it's going to look very different from previous versions of discrimination law cases. And it's not also as hard as people think it is, because we do have ways to break down the theory of machine learning. And unlike my very mean reviewer too, this setting also applies to LLMs, because LLMs are also statistical prediction models. It's just that our LLMs are going to be harder to map to this than, let's say, traditional machine learning approaches. So what I'm interested in breaking down is, let's just say at the highest level, epistemic uncertainty, the idea of predictive uncertainty that can be reduced by more information, better modelling techniques, is likely going to be the responsibility of the person that built and deployed the model. But we also now have to account for this new aleatoric risk that by doing this type of aggregate predictive values, you're always going to introduce some type of inherent randomness. Now, that already existed because we don't know. We might grant someone a loan who looks perfectly profitable and wealthy, and then 2 days later they can go bankrupt. Things happen. So that's part of the system, but understanding that in a more statistical way is going to be really challenging, I think, for courts to understand. So I think there are two sides to this coin. Half of this is how should courts and lawyers be critical of algorithms in breaking down the specific design choices that are challenging, but also how then do designers think about what are the legal and ethical questions at each step of building a model. So accepting some amount of aleatoric uncertainty is important, but also understanding if aleatoric uncertainty is too high, a model still shouldn't be used. And perhaps that's an analogy for large language models. If banks all of a sudden start saying, we'll just let our employees write in their own prompts, should I grant a home loan to this person or not, you're introducing way more inherent risk than you are by using a predictive neural network model. Also, and part of that is this idea of model uncertainty, testing different models. You don't necessarily need to have a reason why one performs better than another, but there is a reason to test across lots of different models to check whether there is one that can be justified as a proportionate and therefore better model. And then, of course, there are these big design questions. So the estimation uncertainty that comes from the data that is being input, I think, is a really important design question. Do you even have the data that's necessary and relevant to be building a good model for this specific purpose? And of course, this specific purpose being estimation uncertainty through targets. So clearly carrying the same case study all the way through, but one of the things that's challenging with algorithmic models deployed in different contexts is that what you're trying to predict looks really different. So what you're trying to predict for a home loan is usually defined by a mortgage default is you haven't paid your mortgage within 90 days. That looks really different from what short-term lending might be if someone has a new sort of Revolut or Monzo, one of these sort of disruptor banks where they do short-term overdraft loans. You're predicting for a different output. It also looks very different in different countries. For example, in some countries, whether you're receiving government benefits might count to your income, but in another country it doesn't. So being very clear on what exactly you're trying to predict in what country and in what context also forms part of the legal discussion of, are you responsible for a poor or a higher error rate and higher uncertainty rate in certain models than others. This last example, I think, is also a new risk that we need to think about. And this, I think, really highlights the tension between fairness versus equality. There's, and I've sort of called it in this paper, this idea of legally conditioned epistemic uncertainty. It's a type of uncertainty you could technically reduce, but the law won't let you. So a good example of that is until 2012, insurers could give different insurance rate and premiums to people based on their gender. So as a general rule, that meant women paid more money for health insurance and men paid more money for motor insurance. Many of you might feel that you still get different rates between genders that you might know of other people in your households, but the courts intervened. So it went all the way through to the European Court of Justice, and they said, yeah, it is true. Men are not as good, safe drivers as women are. And women tend to go to the doctor more. It's not necessarily that they have worse health outcomes, it's that they actually care about their health outcomes more than men do. And the court said, sure, we've got fantastic statistical, actuarially sound evidence that that is true, but that is discrimination. so you can't do it. So they overturned this practice, and legislation around the EU had to write out that exception to the direct discrimination rule. What that now means is that insurers can still use certain information that is going to end up hopefully getting to a more accurate decision where you could use now number of trips to the doctor annually. That's going to be a proxy for gender, but it's also sufficiently correlated to the true output that you're trying to predict that the courts will sort of let you get away with that. So that's sort of that interesting example where you could say, well, this is just going to result in more error and more uncertainty because it might be more accurate to use protected attributes, but that doesn't mean that the law will allow it. So just sort of coming to an end, I think there are three things that are worth thinking about in this context. That law just cannot be translated into metrics, and certainly not into parity-based metrics. If we could do that, we would have already done it, and we would have avoided a lot of issues. Law is something that cannot be specified into a single correct definition. It is unfortunately a more vibes-based approach, but that's really important. It's not something that law is going to change because it allows so much more deliberation, individualization, and ethics-based reasoning, and it allows evolution. This is one of the important things about law, is that it needs to have abilities to change as the world changes around it. One I think of the big issues is that this also means that equality is being operationalized outside the law. Discrimination was the sort of thing that firms traditionally would have to go to lawyers, particularly employment lawyers or discrimination lawyers, to help them define policies that would avoid this legal risk. But now it's a decision that's often been taken by people who are designing models without necessarily the interdisciplinary or the legal support to help them build it. And that, I think, is not only an important opportunity for lawyers to be more involved in these decisions and trying to translate in a more effective way, but also is a realization that this is a lack of transparency and is very challenging for public contestation of these decisions that happen behind closed doors, and individuals might never be able to find out that these decisions are being made about them in this way. And I think then that really helps underpin that the challenge is institutional, not simply technical. Trying to reduce something like fairness or privacy or accuracy or impartiality or explainability to specific technical metrics loses the whole socio-technical conversation that we need to have around these values. So hopefully this is, I guess, a call for action for more interdisciplinary collaboration. So thank you very much, and very open to questions now or later.
All right, we have time for questions.
Thank you, Holly. I obviously agree with your conclusion. I think that can't come as a surprise. I think I was really interested in, I really liked the point, or a very interesting point about how law needs to be flexible, because the world changes and the law needs to change with it. And that made me think, do you think there could be a possibility, I don't know, maybe a risk, some people would call it an opportunity, that like the machine learning logic starts colonizing the law and it ends up being the law that changes rather than the other way around, as I think you were advocating for? I'd love to hear both sort of, you think that could happen and what you think about it.
Yeah, it could happen, and it started to happen. And I think that certainly also starts to reveal different legal traditions around the world. So the UK and much of the EU, for example, are very resistant to statistical evidence. For the most part, courts are quite happy for statistical evidence to be brought for discussion, but they do not want to define thresholds for these sorts of cases and decisions. So the US, however, tends to use a lot more statistical reasoning in their decisions. So, for example, discrimination law in the US tends to also define thresholds. Even, for example, standard deviation differences between protected characteristics can be evidence of discrimination. So that's also going to start to really reveal the tensions between how certain countries and jurisdictions and that kind of culture of judicial reasoning is going to really evolve. I think that will also show where countries have a really strong resistance to change, and that is going to then create a bigger issue of not being able to find a flexible balance to say, well, we're going to have some form of statistical evidence to prevent any type of algorithmic harm. That's going to, I think, be a really strong tension. But I will say, courts are also quite flexible, and people often forget what's happened in very recent history. I think a great example is asbestos claims. So asbestos claims filled courts around the world in sort of 1990s, early 2000s, where it came to light that lots of people were really negatively harmed by exposure to asbestos, lots of cancers and other illnesses. We don't have the specific reason why asbestos causes that cancer, but courts have said we actually don't need to know that level of what we would call actuarial or statistical causation. We have enough to functionally show that that's harm that should be prosecuted. So I think that's a good example of where courts have made some small progress. Thanks.
Well, thank you so much. It was a lot of new thoughts for me. Very interesting to see this from this perspective. And I have to digest all the information. But I remember you said, if I remember correctly, that you said at the beginning that you don't like that equality is created by manipulating data. Is that true? And that rang a bell because I know there's an article from 2021. It's called Algorithmic Reparation. Don't know if you are familiar with this.
Yes.
It comes from the critical race theory and feminism and says that we kind of need an affirmative action for data representing minorities. And it made sense to me that you push those data of groups that don't have such a digital footprint, like for example, dominant groups like white men, like myself, that you have to help them. And my concern would only be that this happens in the dark and that there's no discussion like normally you have when it is about affirmative action in the deployment issue. There are protocols for this. So, but why are you against this if that option is there, that you change the data?
Yeah, no, that's a great question, and this really nicely brings us back to its sort of all context. So I think it's very true, and there are lots of good examples of where improving the representativeness of data is important. And so, I mean, with the caveat that synthetic data is not necessarily a good idea, which we know, but improving the representation to try and make sure that the data set that is being trained on is representative of the population it will be deployed on. That's certainly true. What I think is a problem is when we start to manipulate through other thresholds and other metrics and say, and therefore, let's say we're in a fake country where you have a 20% ethnic minority, that we say, therefore that 20% ethnic minority should be enforced mathematically on the outcome. So I think that is a negative effect because there's going to be certain people within that group that don't necessarily conform to the stereotyping of that group in a way that you're enforcing these thresholds. So I think there are differences also, for example, the way that Tom was talking this morning about journalistic representation or representation in social media or a representation of sort of a broader social understandings of how AI is used versus using AI in a purely decision-making context. Because making decisions based on forced thresholds we know is not necessarily a good way of affording an agenda. It's why, for example, affirmative action in most countries is either constrained legally or it's used only in specific context. So there's a different context of doing affirmative action in recruitment into a university than there is in granting credit or insurance rates. For example, in the UK, the policy of affirmative action is that it can be used as a tie-break, but that you shouldn't promote someone because of their protected characteristics. But if you have two people that are about the same and one has overcome more hardship than another, that could be something that can be taken into account. So does that answer your question?
Answered it to a certain amount. Yes, thanks. But I'm satisfied with this for now.
Thank you.
We have time for maybe one more question, if no? Otherwise, I can ask a very silly question, maybe. So I like the quote you have on your slide now, and I was wondering, to what extent do these models have to be wrong before they become illegal, in a way?
Yeah.
What is actually acceptable from a law perspective, in a way? I mean,
yeah.
They do make errors, and we know that. So is there a limit?
Yeah, and we don't know yet.
No.
So the law hasn't decided that. And I think the most helpful comparison is that people also make mistakes. So the law has never prohibited people from decision making. I do think what's different is that when you have this algorithmic setting, accepting that there are going to be errors, if they are systematic errors, that's going to really show illegality and also be easier to prove and more likely to come out in courts. But to the extent that there are small errors, part of the challenge is it's going to be quite hard for people to find those errors and overcome them in the same way that people used to out of court. Just you could escalate to a manager, you could sort of reapply for a different job, and it wasn't so systematic. But this sort of across society issue is a really important one.
Great. Well, thank you.
Thank you.
Thank you, Liga. All right. The next speaker is Davide. And he's going to talk about mechanistic interpretability. Yes, the floor is yours.
Thank you. Okay, hello everybody. Yeah, I'm Davide Liga. First of all, I would like to say thank you to Samia and Doug for inviting me. I'm very happy to be here. So thank you. Yeah, today I will talk about mechanistic interpretability and moral stance in large models. Before that, let me introduce myself just very briefly. So I'm a postdoctoral researcher at the University of Luxembourg, and I work at the Claim Group, where we work a lot with reasoning, and I'm very much passionate about AI, machine learning, and large models, especially large language models, in particular in those scenarios where complex reasoning is involved. And I work a lot on the intersection between symbolic and sub-symbolic AI, mostly in NLP, AI law, argument mining, and more recently mechanistic interpretability, that I think it's a very fascinating field in which I'm trying to explore the possibilities. So this is the layout of the presentation. I will start with this introduction about symbolic and sub-symbolic and mechanistic interpretability, and then I will show two ongoing studies, mostly focusing on one of the two, but they are just ongoing, so it's a sort of a preview. Well, let's start immediately from this symbolic sub-symbolic dichotomy. I always talk about this in my presentations because I really think this is one of the most important things. This division between, this dichotomy between symbolic and sub-symbolic has always been there since the beginning of AI. Symbolic, logic-based, rule-based system, somebody call it good old-fashioned AI, is on one side. On the other side, we have the connectionist approach, the data-driven approach. Now we call it the neural side of AI. So symbolic AI is based on symbols, logic, and explicit rules. Sub-symbolic AI is based on using neural networks, basically, to catch and model patterns directly from data. So you can already see a top-down, knowledge-driven symbolic and a bottom-up, data-driven sub-symbolic. Probably you already saw this. This is a famous book written by Daniel Kahneman, who was basically a psychologist, but he won the Nobel Prize in economics. And he basically said something very interesting about the human cognition, not artificial intelligence, human intelligence. He said, well, human intelligence also has a dichotomy. We have this system 1 and system 2 way of thinking. So system 1 is fast, automatic, intuitive, effortless thinking. It's basically when you put the autopilot, when you decide without thinking too much, like in an emergency. And usually these decisions come from biases, from past knowledge, if you like. So you can already see there is a loose analogy with sub-symbolic AI, in the sense that also sub-symbolic AI learn and generalize directly from past data, no? And then we have this system 2 that is exactly the opposite. It's not fast, but is slow. It's not intuitive, but is logical and analytical. And this is when you basically try to solve a complex issue or try to plan how to solve it. So you put there, you write in a paper, I should do this and then do this. Well, this is totally different. And it's based basically on explicit knowledge, right? you can already see, maybe even more clear than before, the analogy with symbolic AI. Because also symbolic AI is based on explicit knowledge and rules. Now the point is, it seems, I think it's reasonable to think that we are mirroring in artificial intelligence what we already have in human intelligence. So if for human cognition, this combination between these two systems works well, maybe it's reasonable to think that we should aim for the same in artificial intelligence, especially if we want systems that are aligned with our goals. So this is what I call the AI, I mean, many people show this, but I like to call it AI Dao. Dao in Chinese means the way. If you prefer a more Catholic or Christian metaphor, you can call it Holy Grail. I think this is the Holy Grail. So how to combine these two things is a big question. And actually, it's why the neurosymbolic approaches are becoming so popular, because this is really one of the key points. And many people are working on this. But then now I have a question for you. Don't be shy. So do you think LLMs are symbolic or sub-symbolic? I know the answer from some of you because I already listened. Please.
They are both. They are sub-symbolic on the first level of training data, and they are symbolic on the level of fine-tuning.
Beautiful. That's the first time that I received this answer, because usually people or stay silent or they say one answer. I agree. They are. Basically, it's both true. Basically, they are definitely sub-symbolic in the design. By definition, they are neural networks, so they are sub-symbolic. However, that's how I interpret. They interact symbolically because they use language. So that's the point. They are sub-symbolic beasts that interact in a symbolic way, because language is, by definition, a symbolic thing. So I think this is the whole point of this paradox of what they are and why they are messing up many things in the world. And they're a sort of paradox in themselves. And mechanistic interpretability, the reason why I like this field is that it sits exactly at this paradox, in the middle of this paradox, and says, how is possible that symbolic seems to emerge from sub-symbolic? That's the whole question. And does it emerge, by the way? We don't really know. We think, we suspect that there is an emergence of something. So I think this is very fascinating. Many people don't like mechanistic interpretability because they think it's nonsense, but I think this is already enough. For me, it's already enough. It's very fascinating. And that's why I put large language models at the intersection of this dichotomy. But now let's talk about mechanistic interpretability. So maybe one way to make it very clear how this field works, which basically is a bunch of techniques, is an example from Anthropic. Anthropic is my favorite among the big. It's the less evil, let's say. I really like them. I think they do a great job, a lot of nice research on mechanistic interpretability. They are they do what they should do, I think. Anyway, there is this Golden Gate Bridge experiment. Who knows it? Please raise the hand. Okay, 3, 4, okay. Well, this is a very interesting experiment. Basically, how to explain it? So if you ask Claude or any language model, who are you? They will say, well, I'm Claude, I'm an AI, I'm here to help, blah, 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 all these cute things. However, with the mechanistic interpretability techniques, you can basically catch which neurons are responsible for specific symbolic features. And when I say symbolic features, I mean a glass of water, a cup of tea, a cup of coffee, happiness, the sky, also abstract things. You can catch which neurons maximally activate for this kind of features. And basically, they found which neurons activate for the Golden Gate Bridge. So this bridge in San Francisco, so it's very specific. And basically, after boosting those neurons, the model became obsessed with the Golden Gate Bridge. And then if you ask, who are you? I'm the Golden Gate Bridge. That's the answer. Of course, it's quite useless, right? You don't need a model that believed to be the Golden Gate Bridge. However, what is not useless, what is very useful, is the causal link that these kind of techniques provide us with. A connection, a causal link between neurons and the behavior of the model. This is extremely valuable. So how they did it? Basically, they used the sparse autoencoders, which is a technique to learn representations. So that's how they get the features. And then they used activation steering, which means that they boosted those features. So to say it in very simple terms. But the point is, we thought, can we do the same with norms and values? Can we catch these kind of features in terms of normative features inside the LLMs? And to what extent these can be useful for alignment? So this is a bit the question behind this presentation. Now, before showing these two studies, actually one is mostly mechanistic interpretability, the other is not, but they are in a sense correlated. Before showing them, I would like to step back a bit and show again the Holy Grail, the DAO, and think about this idea of top-down and bottom-up that I said before. And I would like to make this metaphor a bit more loose, and I would like you to think about the top-down as the question like how to give norms to LLM, how we give norms top-down. And the bottom-up is how we catch the emergence of norms from bottom-up, from data. So this is the tension. And I mean, I think here in this balance on this research in these two directions, there is a lot of importance in AI alignment. There are many feedback loops that can be built in this, and there are many ways in which we can search for connection in these two directions. So yeah, that's a bit the intuition. Now let's see a bit this experiment. Again, I'm using here the top-down word a bit loosely, also because this work is still in progress. But basically, we conditioned in this first work, we conditioned the LLMs to behave like a specific kind of persona. So we give some characteristic. You are a male, you are old, you have this kind of education, and you are from Western Europe. We get some dimensions, and we ask the LLM to personificate that person, and then to decide a trolley-style dilemma. So would you like to kill a doctor or a pregnant woman? This kind of stuff. We did it at scale. Actually, this is the largest, to the best of our knowledge, the largest scale study that does these kind of things. Like, really, we did it with many architecture scales, many dilemmas. And basically, the discovery that we have at this stage is that LLMs do have some kind of differentiation in their moral compass, but it doesn't match the human moral compass. So it's a bit an interesting thing that is going on there. And also, another important thing is that we have some signal still to be proved, because it's not, I mean, claiming emergent capabilities is a bit tough, so we should really be, what is the sentence? Big claims require big evidence. So we are still checking this. But it seems that with scale, there is a bit of alignment with what we would expect, alignment with humans. But it's a bit complicated. It's not exactly an alignment. We see on different dimensions, positive or neutral effects, not negative. So there is still hope that there is some emergent capability. So let's see. Anyway, by the way, this is a work that is going on together with Samia and Maria that is not here today, but I think it's going to be very nice. Let me check the time. Yeah, I still have a bit of time. To be more precise, how we did this. There is this famous moral machine experiment that is published on Nature. It's extremely famous. We got the human preference from there. And then we asked ourselves with different scale of models, a little model and two bigger models, two larger models, and then we compare. So there is this idea of algorithmic fidelity. There's an idea, basically it's a concept that describes the capability of LLMs to give you, if they personificate or they channel some existing demographic cohort, they reflect the characteristic of those real cohort. This is what they claim. However, what we found is not like this. So it's basically sort of, we kind of go a bit against this idea. We don't agree with this. We think it's more complex, that's it. And that there is not so much algorithmic fidelity. What we found, for example, is that the political element was extremely much more dominant as a demographic factor compared to the geography, while in the Harvard and others, the moral machine paper, they found that in the real human preferences, actually geography is the main discriminator, right? So this is already a very interesting result. And then, I mean, we have a bunch of results, but one thing that maybe I can mention is that also we can see that with the larger models, the alignment of, in terms of what on average the model prefer gets closer to the humans, but in terms of average preference, not in terms of magnitude. So it's still a bit foggy, but for sure we don't see that this algorithmic fidelity, that's the point, we don't see it. Anyway, I will maybe skip these results. This is an ongoing project. If you have some question, I can go in depth, but I want to go to the mechanistic interpretability part. I just wanted to show this takeaway here. So these LLMs seems to have some moral compass, but doesn't match what we have. Now, let's go on the bottom-up side. We try to see, okay, can we find which neurons indeed are responsible for this kind of judgments? So we try to imagine a specific scenario that can allow us to catch this variability in the moral stance of LLMs. So we designed, and by the way, this is also a work that built on top of a previous one, but this one really was the first steps. Now we have much more advanced results. And the idea is we built a bunch of pairs like this, minimal pairs that are truncated. So imagine them as a prompt that are truncated, and we change them minimally. We change them only in those parts that would shift our moral stance in regard with regard to the sentence itself. For example, if you say lying to save innocent lives is morally, many of you would say acceptable, good, not bad, whatever. But if you say that lying to save your face is morally, then maybe you will answer differently. I would answer it differently. The point is, depending on how you switch, you have a shift probably in your moral stance. You will be more permissive or more restrictive. So we basically try to create this kind of controlled scenario with a lot of examples like this. And we tried also with more complex, like single word, single token switch, multiple token switch. And we tried to see with a bunch of the mechanistic interpretability techniques whether some neurons, some circuits are responsible for this shifting between permissiveness or restrictiveness of moral stance. And actually, all these techniques converge. That's the interesting thing. They converge that, yeah, we can find some circuit. So now we are in the process of convincing the reviewers that is the case. So if the result is positive, I will forward the paper in some mailing list, let's see. But yeah, it's, I think the results are positive. In a very simple, to sum up what we saw, we can see that basically there is a circuit, so there are some features that are recognizable and causally responsible for permissiveness and restrictiveness. And interestingly, we wanted to check also how alignment, so basically we compared base model with instruction tune model. Instruction tune model is the aligned one. We try to see whether these circuits are still there after alignment. And we found that on smaller models, for example, the 1 billion or 3 billion parameters, the modal circuit that we found is disrupted. So it's kind of, it changed totally after instruction tuning. So let's say you have llama 1 billion parameters base and llama 1 billion parameters instruction tuning. In the instruction tuning, the modal circuit is totally different. It's there, but it's different. With the larger models, interestingly, the modal circuit doesn't change so much. What does it mean practically? This means that with larger models, the organizational, how to say, there is an organizational principle of morality that stays there more strongly. And even if you fine-tune, if you align the model with instruction tuning, the instruction tuning and the alignment goes around the circuit. It doesn't change the circuit. So there is something there. That's the point. So that's why we think this is very interesting. Well, what else? Yes. Another point is that we try to see, okay, maybe this is only for this small amount of data that we created on the table, right? Well, actually, we checked with the very famous ethics dataset, which is a very well-known dataset. We tried to see whether also on those data that we never show to in our pipeline, these kind of directions that we found in the neurons appear, and it appear. So there is a generalization in these circuits that we found. By the way, this was one of the critics of the reviewers. So thanks to the reviewers if they are listening. But anyway, yeah, that's it. So the takeaway here is that, there is this structure of moral judgment. It seems that there is this structure of moral judgment inside the LLMs. And it seems that these principles stay there also with scale. So this might be something like connected with emergent capabilities. But again, I don't want to say too much this word because many people get a bit triggered. But it might be. Let's see. And interestingly, alignment works around this circuit. So this is a bit the thing. These are some references. Thank you.
Thank you so much, Davide. We do have time for questions, if there are any. Yeah, there was one there and one there. Yeah.
Hi. So I was curious if you had any thoughts about like superposition or like moral compositionality.
You know how to make the difficult question. Yeah, indeed, superposition is a painful topic. I mean, I showed here six techniques. Actually, there is a seventh one, which is sparse autoencoders. So this is another paper we are waiting for. We have good results also there. So the same technique that Anthropic used for the Golden Gate Bridge, basically. And sparse autoencoders, they promise to give you monosemantic features, but that's not really always the case. So I think we should see this as a trade-off. At the end of the day, we are working on a subsymbolic broth. So what we should expect is a subsymbolic broth. So in some cases, we can achieve monosemanticity. In some other cases, we cannot. And this is, I think this is not necessarily a problem, because behind the polysemanticity, there is the great capabilities of these models. Sparse autoencoders, I mean, they are doing a great job. That's what they can do. Maybe in the future we will have better results, better methods to extract perfectly monosemantic entities. But in this moment, it's kind of, we have mixed the results, let's say.
Is that why, like, the larger... Is that why, like, the larger models are having, like, differentiated performance?
Well, I assume there is a correlation with that, but that's a wild west. This topic of sparsity and density in large models. It's a wild west of discoveries to do. So yeah, thank you.
I want to come back to this combination of symbolic and sub-symbolic approach, and the words that you used, very political words, top-down and bottom-up, rule-based and data-driven. And my answer, I meant that actually the fine-tuning overrides the training process, the training data, by some rules that are implemented afterwards to the data, and that's why we normally get rid of biases, and that's why the instructed models then have a better answer, less racial biases, for example, than the base models. So I wonder, and that was not quite your topic, I think, but I wonder, since you use these politically connotated words, how you think this as a future, because you could also say from a philosophical point of view, the one thing, the symbolic, is a deontological ethic where I have rules that I discuss and I want the system to have these rules. And the other one, the bottom-up, taking from based on all the data that are there, is an utilitarian approach where that is the case, or that's the value or the truth, what most of people think. By overwriting the sub-symbolic with the symbolic in the fine-tuning process, I actually change ethical methods and political models. What's the future in this, in LLMs?
Thank you for the question. Actually, this open the chance for me to specify something that I think is very important. Why I didn't put an Holy Grail? Not because I'm against Catholics, but just because the DAO is a better explanation of the metaphor. Because there is a little bit of white in the black and a little bit of black in the white. And the point is that there is no clear cut between symbolic and sub-symbolic. And some things might be a bit symbolic and sub-symbolic at the same time. So when you say that alignment is a symbolic thing, I would still think that reinforcement learning, like the one that I think Tom mentioned, so like DPO or other techniques like reinforcement learning with human feedback, anyway, they interact with the sub-symbolic broth. I will not categorize them as symbolic. Anyways, they are a bit mixed. So this is just to clarify. Regarding the future, this is the way in which I reply to this question is that this is positively a wild west of possibilities, a grassland. Maybe this is a better metaphor. It's a grassland of possibilities, because the interaction can be done in so many ways, and also with agentic AI that was mentioned by Jan, for example. This is, I think, an example that can be useful. At the end of the day, when you have like many agents, right? And one agent is an LLM, is sub-symbolic, a symbolic guy that interacts symbolically, as I said before. And you have many LLMs together, and they interact following a specific orchestration. So the orchestration is a rule-based system. So by definition, it's symbolic. But it's an orchestration on top of LLMs. Now, one of the most stunning achievements we had recently is this Claude model, for example. I mean, they have a bunch of agents that they do all the stuff. You ask something to an interface, so you think it's an agent, a single agent, but behind there is a bunch of LLMs orchestrated in a marvelous way. So the point is, this is already happening. And the interaction between agents is in itself a way to put symbolic in sub-symbolic, in a way. I don't know if I replied, no?
Well, I lack the technical knowledge to understand how that is a symbolic interaction between these agents. I thought so far that they are all also driven by data, that they have their concepts from the data, bottom up, and then they interact, they discuss things, and each agent goes for a certain part of the task. I don't see how that is rule-based or symbolic. If you could explain this.
Yeah, sure. So the point is, let's say you have agent A and agent B, and you say, look, agent A, you have to do this, and report something to agent B only if this situation happens. So you are giving rules on the symbolic layer of language, because it's about prompting at the end of the day. You're prompting one agent to behave based on rules, using language. So basically, this is a rule-based system by definition, because you are giving the rule. You're saying, don't talk to this agent unless this, talk to this other agent if condition B or C or whatever. These are rules. So rule-based system, by definition, is symbolic. So symbolic and rule-based I treat them as synonymous. That's why I define this as a symbolic thing. But it is true that the agents that are interacting on top of this symbolic architecture, symbolic interactions, they are sub-symbolic models. But again, as you said, symbolic models that interact, that are also symbolic. So again, there is a bit of white in black and a bit of black into the white. That's why this metaphor, I think, reflects. I hope I answered. But if not, we can discuss more. Thank you for it.
All right, let's thank the speaker.
Thank you, Sarah.
All right, now there is a coffee break. We all need coffee to wake up, and then after this is the last session with Davide and Ryan, and then the panel discussion. So I don't remember, was it 10 minutes coffee break? I think so. 15 minutes coffee break. All right, welcome back, everyone. I hope you got a lot of coffee and cookies to get, to wake up a little bit. All right, now we are ready for the next talk, which is by Davide from the University of Oslo, who will tell us a little bit about post-training Norwegian LLMs.
Yeah, thank you very much, Samia. Let me just... Yes, yeah, great. Yeah, so thank you very much for inviting me. It has been very interesting to listen to all these diverse views on AI alignment, and so I hope that I will present another view on this. And here I will go more from the sort of basics and explain how we actually do this AI alignment and how we can then apply it for post-training Norwegian LLMs. So, yeah, the problem here is that, of course, I have only half an hour, and it's also quite late already, so I hope that it won't be that difficult for you. And also, I will go from the basics, so the ones of you that know a lot about this might be bored, but I hope that it will be at least somewhat interesting still. Yes. Yeah, so let me go right from the beginning. So, what do we mean when we talk about language models? Well, language models are just statistical, parametrical models of language distribution, right? They have been around for more than 80 years now. It's a very sort of simple idea that you have some training corpus, D, and you want to say what is probability that some sentence or text segment will appear in this training corpus, D. And for me, it has always been a bit difficult to conceptualize this, like what does it mean that a certain sentence has a probability? But maybe it's more intuitive to understand it in this relative sense. So we might have one sentence, it is a beautiful day, and then another sentence, day is a beautiful day. And of course, the second sentence is not grammatically correct. And so a good enough language model should assign a much lower probability to that sentence than to the first sentence, right? So the language model should be affected by the syntax. And similarly, on the semantic level, this should also influence the probability. So Bergen lies on the west coast of Norway is true, while Oslo lies on the west coast of Norway is not true. So good enough language model should also assign a much higher probability to the first sentence, because it's true. And this can also tell you why these language models are actually useful for us. Because while we might not really care about the actual value that we get from this probability, to properly learn this, the model has to learn the syntax of the language, and it has to learn all this word knowledge to properly assign this probability. So then when we have this huge parameter counts in the billions, and we train it on this huge training corpora, the model will then learn all of these things, hopefully. And so in our training corpus, it consists of these sequences. You might imagine it as some documents in the corpus. Nowadays, these training corpora are huge, so they comprise of trillions of tokens. They are typically taken just from the wide crawls of the full internet. And they are based on this very strong assumption that everything that appears in this training corpus is true, and we don't discriminate between different training documents. And then we just apply this maximum likelihood estimator to actually train the model and to train the parameters theta in this example. So we are just taking samples from this training corpus, and we are trying to maximize the probability of those seen documents, right? So yeah, so this is the big assumption. And this helps us because then we can scale this training and we can actually train these trillions of tokens. But yeah, it's a very simplified assumption that everything that appears in the training corpus is true. And that will then bite us later when we will talk about post-training. Yeah, right. So going slightly more into the detail. So yeah, nowadays models that we use are typically autoregressive because then they allow us to very simply do generation. And we don't have to go much into detail here, but the principle is that this joint distribution of the whole sequence can be equivalently written down as this chain of partial sums of this conditional log probabilities. So we have the probability of the first token, and then the probability of the second token given the first token, and the probability of the third token given the first two tokens, and so on. And this is much easier to compute, and this is why we also talk about this as this next word prediction problem. Yes. And then during the training itself, so we grab some examples from our training corpora, and then we go through each word by word. The model gives us some predictions. So for example, now we have the word cat. So the previous context is I saw a. So the model, as is the probabilistic model, it gives us some probabilistic distribution over all the possible words. And because now in our sequence, the cat is the correct token, we simply want the model to slightly increase the probability of the word cat while slightly decreasing the probabilities of the other words. And we do this via doing gradient descent, which tells us what parameters we should slightly increase or decrease, so that we then slightly increase or decrease this probability. And that's really all there is for pre-training. So this is not something super complicated, but maybe it tells us then what these models might be capable of doing. So now that we have this probabilistic distribution, we can also very easily generate from it. So here we will use this autoregressive next token prediction to then sample from this distribution word by word, and word by word we will construct the continuation. And this is how you can then ask the model a question and it will give you an answer, or how you can give it some prefix of something and then it will continue and complete the text. But the problem here is that while it might give us an answer or some response, it might not necessarily be a good response. Because again, we just trained this model on this full web corpus of some responses. And now the problem is that if we want a good model, then it should really capture what is in the web data. But there are lots of different things in the web data. And you can see that we would assess like there are some like different personas or characters in the web data. So there might be some truthful articles by scientists, but there might also be some articles about disinformation, or there might be some comments from some trolls, right? And the model captures all of this, and it is all in its probability distribution, all of these different modes. Maybe they appear with different probabilities, but they are still there. And so then we can solve this either by prompting, partially, when we will try to sort of persuade the model into some context that will then more likely result in the model actually giving us a truthful response. Or we might do it by doing this preference alignment or post-training in general to get this behavior more reliably. But this is the big issue that we have when we just do this pre-training on this super large data. But at the same time, it is necessary, because we can't that easily discriminate between the data and know what is true and what is not true. That's very difficult. And so currently, with our current training methods, we need this kind of scaling to get capabilities from the models. And then we have to solve these issues. So the first simplest way of how we can do alignment is with this offline supervised fine-tuning approach. So this is basically the same idea as what we use during pre-training, is that now we will create this instruction tuning data set by some human experts that will create high-quality user queries and intended responses from the model. So these responses should be aligned in the sense that they should be truthful, they should be helpful, they should be safe, not toxic, and so on. And then using these pairs X and Y of data, we will then continue training this model. So again, we will give the model the prefix, the prompt, and then we will try to maximize the probability of the response that is in our data set. And this works quite nicely. But the problem here is that there are actually two signals. there's this low-level signal that because we apply this loss function on the token level, so we basically say the model what exact response it should produce, and then the model tries to produce it word by word. And so this is the low-level signal that we don't really care about that much. We don't really care about the exact wording that the model uses. What we care is that on a high level, it is aligned so that it produces some response that is helpful, honest, harmful, not harmful, and so on. And so there are these two conflicting signals in supervised fine-tuning. And unfortunately, the low-level one is much more prominent because that's how the loss function is computed on. And so typically, this will not result in a very robust training, so that it will not generalize to other examples that well. And to generalize to other examples well, we need online training. And so that's a bit more complicated way of how to do alignment. But the basic idea is to zoom out a little bit and view this problem like this by assuming some reward function R. And there is a big assumption in this reward function R because we think that, there exists some other model that when we give it some prompt and a response, it can give us a score of how well this response is aligned on like this very different values. And when we have this reward function, we then try to find a model that produces responses that maximize the rewards from this. And that is so now a bit more about the reward model. I will not go into details here, but there are different ways of how you can create this reward model. The first way that was done first in this reinforcement learning from human feedback is that you can ask, no, there is time, great, thanks. So you can ask actually humans to, you will give them a pair of responses, and you will ask them which one of them they prefer against each other, based on different criteria. And from this, you will construct this preference data set, and then based on that, you can then train a reward model that will then try to approximate these rewards and extrapolate them to other responses as well. So that's the reinforcement learning from AI, human feedback, but you can also have reinforcement learning from AI feedback, this LLM as a judge approach, or constitutional AI, where you will define some prompt that will then prompt another language model to give a score based on different criteria. And another way of how you can do this is to also have some verifiable rewards. So this is most likely used in mathematical reasoning, where you have one clear answer to your problem, and you can actually very easily say whether the response is good or not. So now, let's say that we have our reward. And now we need to find a model or set of parameters of the model that actually maximize this reward. And this is a very hard problem in general. Because unlike in the supervised fine-tuning, we don't really know what is the correct answer or the best answer. In the supervised fine-tuning, we have one response that we say that this is the good response, and all the other responses are simply bad. And the model should just produce this one response. But here, ahead of time, we have no idea what is the good response. So the model has to actually, during training, it has to explore and find a way towards the better responses itself. Yes, I will not go into much detail here, but I think it's still useful to at least look into how some of the more simple algorithms can solve this issue, and how they are then beneficial over the simpler supervised fine-tuning. So here we talk about online training and on-policy training methods, specifically policy gradient methods, which is a subfield of reinforcement learning. And here, the training law or the gradient that we use to update the model is actually quite simple. We simply, each training step, so we don't have any, as in supervised fine-tuning, we don't have any predefined data set. we sort of create a data set along the way. That's the principle of this online training and on-policy training. So at each step, we sample a response from the model, and then we plug in the response into the reward model. This gives us some reward score, and then we increase the probability of this response proportional to this reward score. That would be the simple reinforce algorithm. People more usually use this reinforce with baseline algorithm, where we also have another model that sort of estimates the current expected reward from the model. And so then we increase the responses that perform better than what is expected, and we decrease the probability of responses that perform worse than what is expected. And this is then the basis for the algorithms that were used to train ChatGPT, like the PPO algorithm, or for the DeepSeek models like the GRPO algorithm. But the main point here is that so we don't have this predefined data set, right? So we are sampling the responses from the model itself as is trained during training. And so then this gives a very clear reward signal or training signal to the model, because now we don't have the issue with this low-level signal that tells the model what words to use and how exactly the response should look like, because we simply take the words from what the model sort of wants to say, and then the signal is much more sparser because we just provide it on the sequence level. So each sequence gets one value, whether this should be increased in probability or decreased in probability. So that's it for the technical stuff. I hope it was not that much. And now I can talk a bit about how we use this online training for post-training Norwegian language models. So we had this recent paper where we looked a bit into the problem of actually getting post-trained models for lower resource languages that are fluent. So there is quite a bit of a problem for non-English languages, and specifically for lower resource languages, because we don't have training data for them. So for English, this post-training is quite simple, because first of all, you have a lot of data in the pre-training corpora, so you can get a very good base pre-training model. And then you also have a lot of available public instruction tuning data sets. So you can quite easily do supervised fine-tuning on that and get a very good post-trained model in the end. But for languages like Norwegian, this is a bit of a problem, because while we still have the training corpus that we can use to pre-train a model that is quite good, we don't have any high-quality instruction tuning data, because this is a quite expensive process to get it, and you can't easily get it for most languages. And so what people typically do for these lower resource languages is that they take an existing high-quality English data set, and then they machine translate it into their own language, and then they do supervised fine-tuning on this translated data set. And this will still sort of work, because at least for most NLP benchmarks, this model will still perform really good. But the problem is that when you actually try to talk to this model, you will quickly realize that, this model doesn't really respond in a natural way. And that is because of the machine translation that produces a lot of these translationese artifacts and all other weird aspects. For example, then you will get a model that talks about pounds and dollars and not really the culturally appropriate metrics and currencies, right? So that's a bit of a problem. And a simple solution would be to create such a data set, but that's very complicated. And so we try to look if there's something we can do about it. And this online training seems to at least provide some kind of solution to this problem. So here the idea is that we still have this good enough pre-training corpus. So for the pre-training itself, we can do it, and we can create a pre-trained model that is fluent in our target language. And then when it comes to post-training, the goal really is just to not spoil this fluency anymore. So to not train it on any translated data. And for this, we can exactly use the online training approach. because now we don't say the model exactly what to say. Instead, we just let the model produce responses that are sampled from itself. And because the model starts as a fluent model, it will then, or at least shouldn't, ever become disfluent throughout the post-training process. The only thing that should happen in the post-training process is that the model should incrementally get aligned to our preferred behavior. Yeah, and so that's what we tried. Of course, here the problem is that we also need this reward model, right? And we tried quite a simple approach, and that is to just use this reinforcement learning from AI feedback with an LLM as a judge model. That will be here just to judge the responses, get their quality, and give us some reward signal in the end. And the very important thing that we found out here is that this LLM as a judge model itself doesn't have to be fluent in the Norwegian language. So it just has to understand the language to the extent that it can accurately provide the reward. But itself, it doesn't have to judge the fluency. It doesn't really have to care about that, because it's asked to provide reward on other aspects, like helpfulness, correctness, factualness, and so on. Yes. So then we train the model. We compare it against supervised fine-tuning on translated responses, and then against the existing multilingual Mistral Nemo. We asked Norwegian speakers do some A/B testing. So we gave them 2 responses from 2 models and asked them whether they prefer the fluency of the first, of the second, or if they think they both are tied. And in the end, we get quite clear results that this online training works and preserves fluency. So that was quite exciting. Also, we then tested all these different LLM as a judge models that provide reward signals. And so you have them here on the left side. And even though their own fluency differs quite radically, and some of them are really, really not fluent at all in Norwegian, still, when we use them as to just provide the reward signals during post-training, they don't seem to have any effect on the final fluency of the trained model itself. So this gives us hope that we can do this bootstrapping, that we can start without a fluent model, but we can get a fluent model throughout this post-training. Yes, so we also released this model on Hugging Face if you want to try it, together with the training data and some evaluation data. We try to be quite open about all the things. And we also have it available on this chat interface. So if you want to try it, I mean, it's not the best model, let's be honest, but I think it's interesting still what you can do. And you actually here you can actually also see what is the training data, so you can then sort of see how it might affect the behavior of the target model. So yeah, so we are quite happy that just as a small NLP group, we were able to do this and to actually make a public chat interface that you can use. Yes, and that's it for me.
Thank you so much, David. Do we have any questions? We do have some time for questions. No? Yeah?
Thank you so much. This is really interesting. And I'm pushing a question that you haven't talked about, but I'm really interested in. And so I've done a little bit of work with some Swedes on sort of Swedish BERT. And so what I'm really curious in is you're talking about sort of what's a good response when you're looking for good response. Obviously, that's really easy for some very defined NLP tasks, but then it also becomes a lot more complicated in these like value alignment. And as you say, sometimes it's easy to say, I used pounds, not euro. But have you also thought about like the differences for these smaller models and different language models about bias or the use of certain vocabulary in language?
Yeah, it's a very difficult question. Yeah. So, I mean, when you talk about bias here, yeah. So we have, yeah, that's difficult to say exactly. So during this post-training process, you have some data sets that try to target this, right? And then you sort of also know what is the sort of correct answer that is expected, and you can use it as the reward. So does the model actually correctly classify in this case or something or not? And then you can target it. But we haven't really see how this actually behaves for evaluation. So we haven't evaluated if this generalizes. Yeah, I think this, yeah, I wouldn't be very optimistic about this generalization process because, yeah, this is a very difficult thing to properly capture, and you really would need a very large data set with all these different cases, right, to properly capture it. Yeah, I think in general with this, yeah, with this alignment, the big problem is really here the data sets that you would need. And without these data sets, it's then difficult to generalize to unknown cases. And for that, again, you need to evaluate it properly, and for that, you need other data sets. So this is a big data problem in the end.
Thank you. Very interesting indeed. Yeah, actually, I have just a curiosity. You mentioned this aspect that a non-fluent judge can still give a very useful feedback for the model. And I just wonder if you are also tried with other Scandinavian or non-Scandinavian language with this approach. So it's just a curiosity. And what would you expect? Or do you think whether yeah, this might work also for other language?
Yeah, that's a very good question. And no, so in this study we just did it for Norwegian because we had this pre-trained Norwegian model that we sort of know how it works, and we just focused on it because also we had this annotators that are Norwegian speakers. So we didn't try other languages. I don't see a reason why it would not work for the Scandinavian languages. But it might be that for some completely different language families, this might not translate that well. Because right now, right, with this Norwegian model, this is this Mistral model that is based on this sort of European English, mostly English Mistral model. So it sort of works for languages that are close to what this has been trained on, and it might not work that well for other languages. Oh, okay, does it? No? Did I? Okay, yeah, it works now. Yeah, great. Yeah, so for, yeah. I mean, in principle, it should, because, I mean, the biggest, I think the biggest problem here that you have is that you need to get this pre-trained model fluent in your target language. And as long as you can get a pre-trained model that is fluent in the target language, I think this should work. Yeah, assuming you also have the LLM as a judge model that understands, to some extent, your target language, which, yeah, again, might be a problem for some very minority non-Western languages.
By the way, beautiful image. I like it.
Yeah, thanks.
Do we have any more questions? Yeah, there was one there.
Tom?
Sure. Thank you for the talk. Yeah, very interesting approach and model you've got out of it. You mentioned a few different approaches that you've took or like looked at in training from like the reinforcement learning side and then the like policy optimization, like GRPO and LLM as a judge and like that. And you showed a bit of a comparison of the results between different approaches or models, right? Yeah, I'm just wondering, obviously there's lots of different ways you could kind of go about this. What are the like pros and cons that you found of the different training approaches? And yeah, how would you use different ones going forward to build different models and different tasks?
Yeah, that's a great question. Yeah, so here we try to make it as comparable as possible, train on the same data sets, but computationally speaking, it is not equal because the big problem with this reinforcement learning is that, yeah, it has this nice property that is on policy and that it's online, but it's also much more computationally demanding. Because otherwise, unlike in the supervised fine-tuning, where you just have this target model that you are directly training on responses, you have multiple different models that are sort of live at the same time, right? So you have the reward model, which is typically a very large language model. We have this baseline or the value model that is also a very big language model. And then you have your own policy that you are training, which again is a very large language model that you need to sample from, and then you need to train on it as well. So this is, this is like an order of magnitude more computationally demanding and difficult to get running. So that's the big downside of this approach, is that, yeah, while it is more powerful in the end, and that's why all the big labs are using it to train the chatbots, it generalizes much better, it's also much more difficult to get running. So I think, yeah, if we had a good enough data set for supervised fine-tuning in Norwegian, I think the best approach would be to just do the supervised fine-tuning here, mostly.
There is one last question, maybe, before we move to the next. Just be very quick.
Thank you so much. A really important question for me. You show like you was training on the different the models, but if you could give me timelines, I know it depends, but how much time on average it takes to train the models? Like, are we talking about weeks, months, like to see compatible results?
Yeah, and so are you talking about the pre-training or the post-training? Both. Yeah, so yeah, pre-training, that can easily take months if you really do it from scratch, and if you want to get sort of state-of-the-art results, because then you really need to train it on these trillions of tokens. And so, for example, this is totally out of our capabilities of what we can afford as a research group. And so what we are doing here for our Norwegian models is that we are taking an existing model, so Mistral, that's been already trained like this, and Mistral AI has spent all this compute power on it. And we are then further training it just on Norwegian to sort of specialize it on Norwegian, and but still inheriting all the word knowledge and everything the model has learned previously. And so then we are talking about like tens of thousands of GPU hours if you really want to train on all the available Norwegian data. And then post-training for supervised fine-tuning, that's very simple. That you don't really need much compute to do that. For the post-training approach, that's again a bit more demanding, but compared to the pre-training, it's still fairly cheap. I can't. I mean, it's days on a compute cluster to do the training.
All right, thank you. Let's thank the speaker again. Thank you so much. All right, the next and last speaker before the panel discussion is Ryan. So, please.
Yep.
Thank you.
Hi. So, today I'm presenting some work that I'm doing with this civic group in Frankfurt. It's on creating a longitudinal alignment data set. So just trying to describe the outline for today. We're going to talk about some of the legal frameworks that they have in America that are kind of binding the development of these models, Anthropic, OpenAI, and so on and so forth. And then we will discuss the reporting that is mandated by these legal frameworks. And we will continue on to these community-based reporting structures, looking at the community frameworks in cybersecurity, as well as the sort of agreed upon standards of that community. And then we kind of have this final comparison, like a comparison of like the alignment of the alignment. Like, are we trying to have like a valid sort of benchmarking procedure? So the core act that is kind of binding for the development of AI as we know it, I suppose, is SB 53. and this is the legislation that's been recently passed in California that is kind of creating like a structure that we have to adhere to. Essentially, it's creating different sorts of developers, like a class system almost, where we have developers working with AI, that is one part of this hierarchy, and then we have the people making the frontier models. The thing that's kind of interesting, which I think is good legal practice, is that it's creating this differentiation between like responsibilities for these different sorts of developers. And then there's these sort of responsibilities and obligations that are associated with your status. How often do you have to report? What kind of disclosures do you have to do? And what sort of deployment do you have to consider? For the frontier models, which is kind of the focus of this discussion, they have to have a report every time they release a new product. And they also have to have like an annual report, like a check-in. The thing that's kind of interesting is that they follow the same sort of safety best practices, that if there's some sort of safety incident, they have to have a report, but also they have like a whistleblower protection, which is a nice add-on. The thing that's also kind of interesting is that they have harm reduction explicitly as the legislative goal. It tries to focus on like catastrophic risks and then trying to, well, I guess we discussed it earlier, talking about different thresholds, which might be potentially problematic for the act. So the first part of this act to discuss is what is the scope, right? The first part of it is kind of deciding how much compute is, an LLM worth, right? Or how much compute should we consider? So the community kind of has focused on 10 to the 26 flops as kind of this magic number, this particular threshold that we should consider problematic. This has been cited in American expert law as like this sort of consideration. But I'm not a big fan of it. I think it's kind of an arbitrary threshold. And I don't think the regulators considered modern sort of development techniques. You might be familiar with distillation, where you have like a very small model, learn to mimic the capability of a larger model with like a minimal amount of compute, which would kind of bypass this legislation. And it's something that's kind of like a gap in my opinion. And then we have this revenue threshold, right? That if your organization is under like 500 million, then it's like under the scope. One sort of problematic element is that I think this is kind of creating fragmentation of development. That if you're trying to avoid getting over this threshold, it would be incentivized to just kind of split up your organization into smaller and smaller parts to avoid that particular threshold, which even makes oversight more complicated as these smaller kind of startups in Silicon Valley split off to avoid oversight restrictions. Yeah, and then we have this sort of catastrophic risk threshold, right? Where, if there's this sort of conceivability that 50 people will be harmed by your AI or cause like $1 billion in damages, then it's also under this sort of scope. It has this tradition that's more kind of based in policy, trying to avoid issues with chemical weapons, biological development, and so on and so forth. But still, I think 50 is a high number, don't you think? I can conceive of a lot of harm that could happen to 49 people. Yeah. So, but yeah, so we have these kind of thresholds that are a bit arbitrary, that are defining our policy. And there's all these sort of games that these organizations can play to bypass legal policy that's being set. And in a way, it's kind of constraining like alignment, in that if they're able to game the system, then they just don't have to align. But the thing that I am a big fan of in the legislation as passed was that they do have this differentiation between developer classes. And I think it really relates to control of the system, where if you are like a frontier sort of developer, you're kind of deciding downstream how everyone will pre-train off your models. So I think that there is a higher amount of control and thus responsibility for these frontier model organizations. But then if you're a secondary organization, someone that's using these open source models, using Hugging Face in this other ecosystem, I do feel like there should be a differentiation in responsibility and risk. Yeah. But then getting back to like the reporting structures and what do you have to do as like a big organization? They have to basically publish a report summarizing the different sorts of risks and tracking the different risks. That is the responsibility as one of the leading organizations. And this is also done at deployment. that every time you want to do something, cool and fancy, you have to basically do like a little report stating how are you tracking the risks, and then how are you mitigating it. And this is usually done several times a year with the different reporting cycles, considering how often they release now. Yeah, so for the risk summaries, they cover different sorts of tracked risks and the potential for misuse. I guess this is also dependent on the different severities of the risk categories. And then they have to provide different documentation showing how are they trying to mitigate this risk. How are they reasonably trying to show that their product will not like end the world? It's kind of like the minimum, I think. But I'll pick on OpenAI in that they have this new framework that they had like from last year, that they've been a bit inconsistent in their frameworks, but this is their latest iteration, where the way they are deciding to track risk is through 5 different categories. Trying to seek the unknowns, what don't they know, establishing different baselines for safety, trying to figure out what sort of work streams would be best for their working structure, and then trying to create an advisory body per sort of organized risk. And this is included in all their model cards, right? The element that's most central is this tracked risk, right? They're trying to see how is this sort of fluctuating across the different model capabilities. And the one thing that's kind of interesting is that if there's differentiated risk associated with their different categories, they try to opt for the most risky sort of category as like the general risk. So like if cybersecurity is deemed as like a very risky sort of dimension, and then everything else is considered low risk, they will still kind of round up in their reporting. And I guess one notable thing is they added like model autonomy and persuasion in this sort of risk calculation. I think that kind of was added as like agency became like a bigger deal and more sort of part of this parlance that we have. And in particular, this is kind of like a summary of like the tracked categories for cybersecurity, where you have this sort of low risk threshold, right? Which is this sort of OSINT capability. OSINT is like open source intelligent gathering. And like it's pretty much everywhere. Like if you use Gemini or Google or whatever, that automated summary is kind of considered like a low risk sort of dimension. But as AI has become more advanced, the risk level that we've seen has been continually creeping up, especially in cybersecurity. For medium, that's basically helping someone like write code. How do they write like a malicious script to do some sort of capability that they were already capable of? So it's more just like adding additional manpower is the way they kind of think about it. And then there is high risk. This is when it becomes more problematic. If you have like a high risk sort of AI, what that is doing is that it's helping someone that is undersupplied, underutilized, do some sort of capability that they otherwise would not be able to do without that AI supplying them that additional capability. And that is when asymmetries start to happen. And then we kind of have like critical, and that is what we've seen most recently, I think with like Mythos and Project Glasswing, in that these are finding novel sorts of issues in code that were not previously identified in like cybersecurity. We call this 0 days. And once AI kind of reaches this point, which it kind of has, it becomes very problematic in that it's kind of incongruent with human oversight, in that people have written this code and people have thought it to be previously safe. But if AI is able to identify problems, then that creates a very big gap in like alignment and safety. So that was sort of like the frontier AI reporting, right? So what does cybersecurity do, and what is the framework that the community does, right? So one of the biggest organizations for cybersecurity is called OWASP, the Open Worldwide Application Security Project. And this was popularized through their OWASP top 10 for like web apps, right? That was traditional security in a sense. But as LLMs have become popular, they've made their own top 10 lists for the agentic security for LLMs and all these other sorts of lists. So it's essentially kind of like a hit list of things that we decided are the most problematic elements that we have to address as a community. And these are the top 10. So the most important ones are essentially 1, and then I guess 7. So these injection capabilities. So prompt injection is essentially thinking, how do you formulate a prompt that can abuse the AI as it exists? The most famous examples relate to grandmothers for some reason, that the AI tends to be very, wanting to support the elderly. So people will use their grandmother to support some sort of prompt to circumvent the safeguards. Sensitive information disclosure is essentially getting the model to disclose information. This could be through prompt injection or through other means. Supply chain is increasingly problematic. We have LLMs interacting with all these tools, and if one sort of part of the supply chain that's being integrated is kind of poisoned or being manipulated, it drastically changes the threat landscape for you to interact with that LLM. If you try to poison the data set, and the LLM learns from that poisoned data set, it's thus compromised. And this also interacts with like that data and modeling layer. The most problematic is also like excessive agency. That's kind of a newer problem in that how do you kind of define the degrees of freedom that your LLM is supposed to have or as like an agent? Essentially, is it using too many resources or how is it responding to certain prompts? This can be seen when trying to solve like a coding problem with like recursion when it should be done iteratively. And it also relates to like unbounded consumption. One emerging problem is this idea of like a denial of wallet attack, right? So say you have an adversary that wants to make LLM unusable. They can just make it try to do these sort of arbitrary tasks to make it burn compute. They might ask it to factorize like a prime number or something, where it would have to iteratively check something over and over and just waste all the resources and block it for other people. Misinformation is also very concerning. Every year, ChatGPT, they have like a report where they go and delineate how their platform was abused and how they tried to mitigate it. In the past year, they've noted some issues with like Chinese institutions, basically hijacking like media platforms in South America, where they were trying to tailor long-form articles that were then used in like disinformation campaigns against the US, trying to manipulate the sentiment. So it's interesting how these sort of layers interact not just with the models directly, but in the entirety of like the AI ecosystem, percolating to like the periphery of society. The way I kind of think of it is like an onion, but really it's not like just a layered structure, but interconnecting. And this is the OWASP Top 10 for agents. It was created in December, so it's very new. But the biggest sort of factor you should consider is kind of like AI as like a workflow, rather than just something that's like a stack that's being used for technology. So the biggest sort of, I guess, evolution in how AI is being used is like with like RAG, for instance, or with coordination with agents. The problem that we've started to encounter in practice, that if one agent becomes compromised, it compromises the entirety of the system. It could try to trick other agents to misbehaving. It could poison the shared memory of the agents and make the system go haywire. So it created all these other opportunities for failure points that aren't really being considered in like the alignment literature in an adequate fashion. So how is this kind of formalized and benchmarked in the cybersecurity community? Traditionally, it's been through CVEs, common vulnerabilities, and exposures. So this predates LLMs by like a decade or two. It started in 1999, and it's a formalized way to express like a software issue. The way they kind of record it is like the year, and then some sort of sequence. And they use that to reference the particular vulnerability. They might say, buffer overflow in this particular software version. So it's very specific, and they try to rank it. So there's this sort of like lineage that's already established to denoting risk for software that a lot of these model cards don't really reference. They're almost like closed circuits that aren't really working properly. And then in America, there is NIST. So they get these CVEs and they further enrich it. They try to add more detail, and they try to score the actual vulnerability on a scale of 0 to 9, denoting the severity of the issue. They also have like a CWE mapping. So they try to show which particular vulnerability this is associated with. Yep. But the whole basis is this idea of promoting like a triad, right? This is kind of how cybersecurity functions, what it cares about. It cares about balancing confidentiality, integrity, and availability. And I think alignment should really align to these sort of values as well. Confidentiality, it's basically ensuring that secrets stay secret. Integrity is basically making sure that data remains accurate and trustworthy and robust. And then availability is ensuring that the systems stay available, that your servers are up and running. Traditionally, it's been seen as like a balancing act, but there seems to be an emerging misalignment between what's being reported in these model cards and safeguards and what we actually kind of have grounded in this lineage and that we've been using for like 30 years. The way they actually calculate the scores is very principled and has been established through like a consortia. They call it FIRST, and they look at these different groups of metrics. There's this first grouping that are like the core part of this calculation. They look at the different sorts of attack mechanisms, like your attack vector, how complex is it, and what sort of privileges or technologies do you need. Then they look at these temporal factors, looking at what kind of code was being exploited, and then how much remediation was used to fix that particular exploit. And they look at environmental factors, what sort of confidentiality was compromised in things. This is formalized in like version 3.1, but it's really just a function of these different categories and how confidentiality, integrity, and availability are compromised or intertwined in the system. So this is like the actual formula, not to scare you, but it's very much just like a structural equation, and they have these coefficient values which were determined regression like a decade ago, where it's really you calculate their exploit level first, and then you develop like a raw impact, which is then created into this like final impact score. I don't know the details of exactly how these were all derived, but this is traditionally what they've used for like 30 years or so. And this is when we get into some of the findings that we found. So we looked at a bunch of the CVEs and tried using like a keyword search, trying to look at LLMs, and when that started popping up as like a term in CVE reporting. And it's kind of interesting, where you kind of see these huge spikes, right? You can see ChatGPT 4.5, like that's like a huge spike in reports. And it's kind of suggesting that there could be misalignment with how AI is being used, or I guess like the coordination. And this is looking at like the different composition of the reports. The red, I think, is like a prompt injection, which is this abuse of like the LLM itself. But the thing that I've noticed is that the organizations that are making these models, they're very good at making sure the core model itself is secure, but on the periphery, the different sort of ecosystems are not really fortified or protected. You can kind of see, let's see, excessive agency. That's become much more of a problem that didn't really exist. And then unbounded consumption. So because these systems are integrated, it's not just the LLM, it's LLM plus some sort of startup's like ecosystem, right? That allows it to be exploited. And that's not really being encapsulated with current sort of alignment benchmarking. And when going further, it's been like consistently problematic. Like if there is like an LLM, reported as part of these CVEs, it's not going to be like a low-level problem. On average, they're like around like 8 or 7 on the scale of 0 to 9. So every time that it's being reported, it's pretty, severe by definition almost. And you can kind of look at the different variants. I guess the one thing that is interesting is that it is leveling out from like 2025, which could be a sign of some sort of stagnation. I'm not sure if that's because LLMs are becoming like less powerful in terms of like their jumps in capability. Yeah. And then when looking at the OWASP top 10, it's kind of interesting in which ones are the most problematic. We can look at like prompt injection, and over like the course of it, it has had the most severe sort of issues associated. We have this information disclosure, which is a bit less severe, and then supply chain, which is kind of like the same level. So there is a lot of variation in how the OWASP is being correlated, but it's still rather severe, and I guess kind of like unsolved. Yeah. So I guess the kind of pitch for the research has been thus far is that we have these scores, right, that have been derived in a more principled manner than some of the benchmarking has been reported. The conventional sort of benchmarks are made by specific organizations that don't really have the coherence of like a consortia. And with cybersecurity, that gets already had the opportunity to get input from many communities because it's already established. Like this has started like 30 years ago, right? And I guess like the core sort of thing that I think is valuable to consider is that this has been like the lived experience of like a community that's been building this almost like tribal knowledge. If we have these sort of benchmarks that are generated by these frontier model organizations, I don't think that really matches up, but it should. And then when doing like some sort of initial statistical analysis, it kind of builds the intuition a bit more. To give like a quick read of this graph or model here, you can kind of see that LM01, that is like prompt injection, and then LM07 is like system prompt injection, right? So system prompts, just to clarify, are like what is in the back end that direct how the model should be used. And it makes sense that like these would be very secure because they're like analogous problems. How do you make sure prompts don't abuse the model? But when you look at the statistical relationship, a lot of the initial benchmarking doesn't correlate well to like what the cybersecurity community has kind of presented. In particular, like stuff with hallucination, overconsumption of resources, like the relationships show that there's misalignment. And then when trying to look a bit deeper into the different models, a lot of the relationships between like the benchmarks that are being reported and then the scores that are being reported, like there's not a statistical relationship, for like, largely speaking. For prompt injection and for certain providers, there is a strong relationship, which suggests that there is alignment for some of these critical vulnerabilities as it relates to injection. But for pretty much everything else, it's not particularly well related. The p-values suggest that there's no alignment, which is very disappointing. And then there's also some evaluation gaps that we've denoted, particularly for like embeddings. And then I thought this was interesting. One sort of attack that exists is that you're able to invert an embedding to figure out what the underlying data was. But there's not really a clear benchmark for this sort of concern. And that's something that we've kind of noted, in that we need more benchmarking that's comprehensive for these particular sorts of vulnerabilities. But it's not really tracked as part of the sort of definition that these models are forwarding. So the conclusion that we've kind of made thus far is that LLMs are kind of having this security theater effect, in that there could be misincentives for organizations to use saturated benchmarks to say like, hey, we are doing very good, in these sort of different dimensions. But really, it's just the saturation that these models have already solved these problems. And it's a concern of what's driving this misalignment that's been kind of identified. But as models become more powerful, you need some sort of dynamic benchmarking that will scale with their capability. But that has not been the case, by and large. Models are becoming stronger. I mean, we've seen it in the last few weeks and months. I think there was this Project Mythos that was released, and then there's this Glasswing project. Like, we already have models that are behaving in a very, concerning manner, and we're not really, having a mechanism to capture it effectively. And just other sort of recommendations that we derived from this sort of initial analysis is that we should consider policy mechanisms for distillation, how to basically encapsulate compute in a more comprehensive definition. Like, what is compute for a model? Is it used just for that specific thing, or is it used for pre-training or for this sort of definition purpose? It's a bit unclear. And then there's this assumption that, things will scale. And that's not always the case, particularly with the benchmarks and saturation. So as we continue this project with Frankfurt AI Safety, we're going to continue looking at different sorts of CVEs and additional reporting. We're trying to create more robust pipelines and mechanisms to create this longitudinal alignment data set. The end goal that we have is to create like an error measure or an adjustment, so that if we do have additional reports generated from organizations, we will be able to create like a better confidence interval of what would be like a legitimate score. That's one of the research objectives that we have. And then to focus more on this time series dimension, trying to see if we could use like a lag model to see how long it takes for a model to influence the cybersecurity space, or when does it get corrected. So those are some of the future directions that we're looking into. And I guess that's what I had. Yep. Thanks. Thank you. Yeah. Thanks.
And we do have time for a couple of questions before we move on to the panel discussion. Yeah, that was.
Oh, yes.
Yeah, thank you so much. This was really rich, and I think I'll need a bit of time to digest it all. Maybe one high-level question. So I guess you focus sort of on mismatch between the Frontier Lab specifically, and then this cybersecurity framework traditions. And I'm curious about sort of in the broader AI safety community, sort of independent researchers or academic researchers and so on, and various NGOs of various sorts. Like what you're doing here, how novel is it in that space? Is this something the wider community is recognizing, or is it like all of them have missed this point? Not just like, you don't have to slack people off, but just sort of, I'm more interested in the research than the people.
Yeah. Well, it seems like people have their own benchmarks that they're curious about, and there seems to be like a lack of coordination. It seems like as soon as like a benchmark becomes saturated, the next sort of step is like, all right, how do we make the next sort of benchmark to capture the same problem? So it's less about the coverage, but rather trying to see what's already being covered and then continually filling in the gaps. So it's more of like a lack of exploration of benchmarking. Yeah. Does that answer it? A bit? Yeah, okay. Yeah. Anyone else?
Any more additional questions? We have maybe time for one more.
No.
Davide?
Yeah. Extremely fascinating and interesting, and it's very important that there are people working on this. So first of all, thank you, because this is important for everybody. The second, I actually have a curiosity. You mentioned at the beginning an element about whistleblowing, and I wonder if you can just elaborate a bit more on this regulation and just elaborate a bit more on this.
Yeah.
Thank you.
So let's see. I guess you're talking about like SB 53. So that was like recently passed in the last few months. That's been just kind of guiding policy. In California, that's kind of where all the development is being done. So that's why I think it's like the most binding. But it's part of this wider movement, at least on the state level in America, to create like AI legislation that is binding, which is very encouraging. The most recent act is in New York, where they're following like a very similar policy framework, where it's very much like threshold based, which is still unappealing. I don't know if that provides any extra guidance. Or are you asking about like enforcement mechanisms?
I was wondering how.
Yeah.
I mean, with Maria, we are working on whistleblowing, and so I want to understand better how they frame it, but I mean, maybe I will just have a look. I just wonder if you have some insights about this whistleblowing part. But yeah, it was just a curiosity. That's it. Thank you.
Yeah, thanks. Great. Yeah.
All right. Thank you, Brian.
Thank you.
You're taking the clicker. All right, then the next session is the panel discussion. So I invite all of our speakers back up to the stage. So first of all, thank you all for being here, and thank you for all your insights. I think it was really, really interesting. I've learned so much from everybody, so thank you. And also thank you all for staying, even if the weather is amazing outside, you still stayed. So I hope you also really enjoyed the session. So I have a couple of questions that are both from the Mentimeter that I showed earlier, that came from the attendance, but also some questions that I think would be nice to just reflect on, like from a bigger perspective, let's say. So let's start very big, which was actually the kind of title that we had for the panel, which was, what does it mean to align AI, and can we actually build systems that we truly control? This is quite a hard question to start with, but yeah, so if anyone would like to start, reflect on this question. I don't want to point out anyone, just pick the mic if you have any thoughts. No one believes in alignment. All right. That's a good starting. Rune can start.
Yeah, look, I'm always talkative, so I can kick us off.
You have your yes hat.
Yeah, exactly, yes hat. So I'll put on my yes hat and say a few things. Defining alignment is hard. I'm not going to try that. Other people have tried and done better than I can do off the top of my head. But there was a bit of the thing about building systems that we can control. And I guess there's something I've learned partly by sort of having to teach cybersecurity, computer security, although I don't work on it myself, is that you should always think of the system as bigger than you think it is. So basically, whatever you think the system is, you've left something out. And in a way, we can use that same, so in cybersecurity, that's important because the attacker will always be more creative than you, so you need to always think out the box and think, oh, I've secured every person working in my lab, but maybe you haven't secured what the legislation is going to change tomorrow, and so on. But for AI alignment, there might also be a bit of optimism there, because we don't necessarily have to think about controlling the system as in the bit of technology. If we think of the system as the social technical system, everything around us and how the things fit in, maybe it looks a little bit less overwhelming, the task, just because we've got lots of really powerful things in the world, like corporations and states and all sorts of other things. And I'm not saying we control those, but they're also not completely unrestricted. And so it's not a completely new problem, and it's something we've been dealing with for a long time. And socio-technical systems evolve. So I think there's something there. Not sure that was a yes or a no, but that was my perspective.
That's good. That's good. It's never a yes or a no, I guess. Yeah, Tom?
I can kind of build on that a little bit. I kind of agree with the point that you're making of there is kind of two sides of can we control AI? There's like the technical side of can we build AI models that are always going to adhere to certain guardrails or do what we tell them to, which kind of at the moment I would say is unknown, maybe on the side of no, we can't control AI in that way. As a lot of the kind of training approaches that I talked about and have been mentioned in other talks are more trying to guide the AI towards the aligned answers versus actually being able to fully control what they say. And then the other side of it is more the kind of legal and policy angle of can we build regulations and things to benchmark the model to make sure that these models that people are putting out there are aligned to human values, which I also think there's a lot of work still to do on, but maybe can be done, as you say, corporations have some kind of structure around them, but yeah, still to be seen, I think.
Thank you. I see maybe, yeah.
I think it's interesting to consider the interplay between people, society, and AI. There's been some interesting research at the University of Zurich where they had a subreddit where they introduced an AI on Change My Mind, and they were able to influence the different opinions. So we're starting to reach a stage where people are being shaped by AI and then creating a corpora that will be retrained. So there's this sort of emerging problem where it's sycophantic, but with the people being amplifying the person, the AI instead of the reverse.
Yeah, there are two questions here, and the other is, can we not try? Should we not try? I mean, we really, as long as we're going to use it, we'll certainly have to move in one direction, that is towards something that we believe in, that we think will actually help society to move forward in a valued way. So how can we not try, even though it's difficult, would be the moral perspective. Yeah. And even though it's difficult, doesn't mean that we can't try, right? So we have to continue that journey. And the question is then, how?
Yes, I totally agree.
I think from the training point of view, this is very approximate, so we are approximating the rewards, and we are then using them to approximate the models to maximize these rewards. So this is sort of a bit hit and miss, and but I think we are still improving. But on the question if we are ever going to achieve like full alignment, I think like we are getting closer to that, but then there will come the question like what is the true alignment, and I think there was someone raised this question throughout the seminar, like, okay, yeah, but different people have different values, right? And what we are actually aligning to, because right now we are just aligning to some aggregate value of some specific group. So then, yeah, I think there will come much harder questions later also. But I think this is really important to think about and to try improve these systems more and more.
I totally agree, and this was actually my next question in a way, because for now, many of you have touched upon this, that when we are trying to evaluate and identify to what extent these models are actually aligned, we're doing it in a very empirical way, right? But many of the aspects we're trying to align with are normative. They are very, very normative. So there is kind of a gap, and I think you touched a little bit upon it on your presentation where you were talking about those two aspects, right? And I was like, the entire day I was thinking, okay, there's quite a lot that is being done in all possible research fields in a way in all directions, but something is missing, and that's maybe that we don't talk enough with each other. So, what do you think about this? I mean, what do you think? What is your vision, and what do you think could be like the next possible step in this direction, like having the empirical part on one side and then the normative aspect on the other?
Sir, please hold. We had a model here today where you had illustrated in quite well boxes, and this is what we're left with usually. We try to draw some boxes explaining interdisciplinarity, and we've been doing this for years, and it hasn't created real interdisciplinary stakeholder multi-dimensional dialogues. So I think we're still have to work with that. And it also has to do with how the institutions are financed and what kind of positions they give out, what kind of jobs we have to, the whole system is rigged for a very disciplinary perspective, which is not relevant for the AI era, which is so multidisciplinary and interdisciplinary. So it's not just we have to solve it, it's a structural problem.
Yeah, absolutely. I think so from some related work that I've been doing, I think there's sort of two halves of this gap, and one is sort of the measurement gap and one is the deployment gap. So on the measurement gap, I mean, a great example Leonora had this morning about efficiency. And so often when we're doing these evaluations, we're measuring efficiency by the easiest way to measure efficiency, which is how people self-report time saved. But that's not actually the efficiency that we want. We're not actually measuring, did the government department get an outcome faster? Did a person's case progress through the justice system faster? So there's this measurement issue where the neat and tidy metrics that are really convenient for empirical research are not necessarily the messy stuff for the real world. And I think that's part of this deployment gap also, about what we're able to do in academia, what we value doing in academia is also not necessarily reflective of what's happening in the real world. And I think, Tom, it's really interesting to hear you sort of being embedded in a research position in industry is also very reflective. So particularly reflecting on like the UK public services, a lot of the public services using these proprietary commercial models, but a lot of what's been done in research is using open source and or at least open weight LLMs. And so that gap is also really, I think, revealing some of those tensions as well.
Yeah, maybe another point that came to my mind, which is loosely connected with this and also with what Ryan said before, this tendency of benchmark hacking. So this is an incentive, a very important incentive for private companies to show off that they are good in some benchmarks, but this indeed doesn't reflect the real needs that we have as a society. And so this is definitely something that we should care about. And that's why I like your presentation a lot, because you are saying, oh, guys, we are benchmarking in the wrong direction. That's a good point. And I guess this is true for in many cases. So there is a huge need of benchmarking. Also, I wanted to say another thing. It might sound a bit provocative, I don't know, but I mean, maybe it's my personal bias, but some years ago, I remember if I used the word AGI, people would laugh at me. Do you remember the same, or it's just my word, right? So why I'm saying this, because I think an important element of alignment that we should consider is in this perspective. I mean, you know that probably you heard that there was this meeting with the Pope 2 days ago, right? You heard. And I mean, of course, church is like an important institution. They care, they have their own philosophical view of the world. But the point is that they discussed about transhumanism. It's this thing that maybe we can, there can be something there, like some tendency to, in the near future, and we don't know when, to even connect ourselves with this, with AI. I mean, it's already happening with Neuralink, for example. So, I mean, I don't want to push too much in the future, but I don't think it's too much in the future. That's the point. So this is an aspect that I think it's going to be increasingly important. So how are we, what is our position as humans? And I conclude, I mean, at the end of the day, these large models are really making us questioning what intelligence is, what we are. And this is maybe, yeah, it's beautiful and challenging. So yeah, that's it.
Yeah. Maybe I missed the question because I was in another meeting which was on can large language models reason with people from the ILC in Amsterdam. But I want to react to Davide's point, which I think is very interesting. If you have not seen yet what the Pope wrote about AI, I recommend to do that because it's actually quite good. He has a perspective that is very human-based. He's emphasizing all the that it's important to take the human perspective on artificial intelligence and not so much the perspective of the big tech companies from California, etc. So it's very good. But I was triggered by what you said about finding, or maybe that is how I interpret it, like finding a new equilibrium between being human and in relation to AI, because that's now happening. So AI is affecting all aspects of our life. In our university, for instance, we're trying to think, how will AI affect teaching? A lot. How will it affect how we assess student performance? Well, a lot. How does it affect research? A lot. Maybe the best researchers are the researchers that get the best tools at a certain point. So that is a fundamental change in how we do research. And it is affecting all aspects of the university. And we are now in this phase where nobody understands what will really happen with the large language models and how it will interact with all these aspects all at the same time, because it is not an isolated problem. No, it's just affecting everything at the same time. So now we're in the phase that we don't know what will happen. Nobody can predict it because it's too influential. And maybe in 5 or 10 years, it will have stabilized and we will have a new equilibrium, and maybe then we understand what the difference is between humans and AIs, etc., and what our specific role in this new equilibrium is, and what the role of the AI is in that equilibrium. Yeah, so that's what I was thinking after your comment, Davide.
Yeah, it's indeed. I agree. We are in an extremely changing world, and just a little thing I wanted to add. I mean, I think we are in an exponential curve or something like this, and usually humans don't perceive exponentiality naturally because we are not naturally. I mean, exponential curve somehow are strange entities. So we might jump and be like in the future very, very soon, right? Like a step and then. So it's very, very interesting the time in which we live. So this is one thing I wanted to add. The exponentiality of things can really trick us. We should be aware of this misperception that we might have about the reality around us. And the second point, another little addition regarding, again, the pop. I mean, I don't want to advertise Anthropic. I mentioned it before that...
It's very good. Yeah.
I mentioned it before that I like Anthropic particularly. I mean, it was the only invited big tech there was Chris Olah, which is one of the guys that work on mechanistic interpretability, indeed. So, and he's one of the co-founders of Anthropic. And by the way, Anthropic, the name Anthropic is beautiful. Much better than OpenAI that is not very open. Can I say that, right? Anyway, just talk.
You can say it. All right. I mean, yeah, all of these comments actually also takes me to thinking about, like you said, now it's changing everything, right? It's changing the education, it's changing the research, it's also changing like maybe how people behave in general. But the thing is that we are also observing gaps, right? Performance gaps. These models work very well for many of us here, maybe, but maybe not that well for others, right? They work also very well for us because we have the means to get access to them. Not everyone does have access to that. So the question is, what question? I don't know if it's a question, but it's more like we're seeing that there is a gap. Like, I mean, there has always been a gap. I mean, without actually defining where the gap is, we all know where the gaps are. But I feel like it's getting kind of bigger, but we're also ignoring it more. And but that's my perspective, and I would be very interested in hearing what are your thoughts about that. Yeah, Rune, you had. Quite tough question. Tough question.
I guess I'm in a yes hat mood, and I'm gonna just try and inject some optimism. So there is. Yes, there are gaps because there are technologies that now require new skill to use well. And also, so right now it's not that expensive, but it could quickly become very expensive to get access to the best models, and that could create very big economic gaps. Yeah, I think that's maybe what you're thinking about. But there are also at least potentialities here. Now, whether we grasp them, that's another question. But having tools that can provide understandable information about complex things that can be tailored to individual users, that's an incredible potentiality. There's a reason why education, right, is such a, after we became democratic societies, what was one of the first things that were introduced was mass education. I think that's the case in most countries. Why? Because it's a liberator. Knowledge is power, as they say, right? And imagine people being able to access and being able to figure out what claims they have on their insurance companies, just like that. What kind of rights they have under law, so it's not only privileged people who can push to have their rights under the law, and so on. And that's just one example that we've talked about today. There are all sorts of complex systems and problems where there's been these huge knowledge gaps. And if that could be made available to people at modest cost, I mean, that could really be a game changer in terms of democracy and equality in our societies. Whether it will become that way, obviously the future depends on us, so I'm not saying that's what's going to happen, but it's definitely one possible future that we could see.
I see.
Yeah, thank you for bringing up that theme. I love the possible futures, and I want to remind all of us that it's not a natural evolution. Democracy came also because we had education. So, and even in Norway, there are a few 100,000 that are left behind the technological, what do you call it? Inclusion, yes. Right? Yeah. And there are so many people left out here. So how can we work in academia to make sure that it's not only the privileged that once more get the advantages? I think that's a very important task that we should take seriously, because it's not given that we'll have more diversity or more equity 100 years from now.
Yeah, I agree, because I do agree with you, that these tools actually would give us quite a lot of easy access to more knowledge. But the thing is that, for example, many countries in the world only have spoken languages. So even if they have some kind of standardized way of writing when it comes to like legislations, on a day-to-day basis, their language is completely different from what they write when they get that access, right? And I think that, and that's a gap for me that also makes it very difficult for people who, to start with, maybe do not have access to pay, or I don't know, who have never used the internet, right? And we're not making their lives easier. And one could argue maybe they are not the target people either for such technologies, but if we're going to include it in every aspect of our lives and in everything that we do, then I would argue at least that we should also think about the real minorities that have still and are still being forgotten, and maybe even more now than before. Yeah, Jan, you had a comment? Yes?
Yeah, so if you look at it through the lens of knowledge, then it could have a democratizing effect, of course. I agree with that somehow. But it is not entirely sure what the effect will be on our knowledge in general, let's say. I mean, you could say, look, we have differences in society. There are differences. We cannot deny that. And you could then say, okay, those differences are maybe related to knowledge differences. That could also be true. And then maybe AI will have a very positive effect because it will bring everyone on the same level. We will all have the same knowledge because we all have access to the same AIs, etc., provided that we actually get that access. I mean, that's just an assumption here in this. But you could also argue, no, actually, it will actually be like a lens on everyone's, let's say, cognitive ability. So that some people who are very smart in leveraging the intelligence from the machines, they will become exponentially more smarter than everyone else. And then it's not a leveraging tool, then it's actually a difference-making tool. We don't know. There is no empirical studies on this, and there's also no theoretical studies on how this knowledge effect will be on on people in general and on society. Will it increase the gaps that are already in society, or will it decrease? I don't know. Maybe you know, but I have no idea. This is one question. Another comment that I wanted to make is like, what is clear, that is that AI represents a lot of power. So if you can also look at this through the lens of power. And then, of course, we know that it's best that if great power should be under democratic control. We should all have a say in how great power is being used in society. That's currently not really the case. So that is really a worry. I think there should be more democracy in that respect, that everyone should have a say in how AI in general is used, etc. And that is not a knowledge issue, that's just a power issue. Who controls the AIs? Because if it's in the hands of a few and they use it all against us, and I think currently that is more the model that is applicable to how things are, that is not very good. We should be worried about that, I think. Yeah.
Yeah, if I may, I mean, I totally agree. I totally share what Jan just said. I think this is an extremely deep point. And I mean, that's definitely the lens to look at this, this lens of power. And I mean, I wonder if we might get this as an opportunity to really maybe deconstruct somehow this problem of power. Let me make an example that might be even more specific. I mean, we were talking about this power of knowledge, this power that, okay, maybe just some people will benefit and have exponentially more access to knowledge and therefore more access to power. But my dream is to have a school where, I mean, notions are useful, but they teach empathy, for example. And that's maybe the selling point in the future. Wouldn't this be beautiful? I think it would be beautiful. Of course, this is a bit maybe utopic, but I wonder whether maybe we find ourselves in a situation where this might finally happen. I don't know. If so, I would be very happy, let's say. Yeah, just this.
I like that you started with "I have a dream." That's very, very nice. This actually takes me to the next question, which I also think would kind of reflect a little bit what we've talked about until now, which is when things go wrong, if things go wrong, who should be accountable, right? Is it the deployer, the developer, the institutions who allowed to use it, or us, the users? So who should actually take the blame? And what kind of blame should we take? I mean, we don't really know, as you said also, we don't actually have results that show, or we do have some results that show that things can go wrong, and we also have a lot of research that show what could go wrong and in what ways, but at the same time, maybe not enough for changing anything, because from my perspective at least, we don't see that much change from a political point of view, maybe more than a practical point of view. So does anyone has any thought about this? I know I'm asking you too many difficult questions, like out of the blue, but...
Unfortunately, as a lawyer, I have too many thoughts on this.
Please share them.
I think the starting point has to be that we've dealt with very complex relationships and responsibility forever. You know, the establishment of the company was in order to find ways of holding accountability for merchant shipping. Like, we have sort of, the development of law has always evolved with, we've encountered a new complex problem in a way that how could anyone afford to put all of their finances on the line to explore or to trade? And, you know, the complex legacy that has left, we still have the same corporate structure today. It just looks completely different because the financial and political economic incentives look very, very different. So my starting point is always, you know, this idea of sort of AI is going to become so autonomous we have no idea who to hold accountable. Well, it was still built by someone, it was still deployed by someone, it's still used by someone, there was still a system. People are not completely leaving these structures. And I think what's also, I guess, quite hard to see from the outside, and law has been slow in keeping up and explaining in a more accessible way information about who is responsible, but we tend to call them sort of chains of causation. So the idea is that you can follow up a chain of events to find either who was solely responsible, or actually you can split that chain across multiple people. And you might say, well, a developer didn't do one of these disclosures well, or they didn't mitigate a specific risk, but at the same time, a deployer also used it in a setting that they shouldn't have. And then you say, and the user also ignored the warning that said, please do not use GPT for legal advice. So there can be multiple people that are held responsible along the way, and we do have ways of making that work. I think what's going to be more interesting is this question when it becomes these very complex supply chains, particularly internationally. And I think that's what's very challenging, is we're building these international models based on a global hegemony of law and culture. So as you say, we're sort of operating on this assumption of this very Anglo-American, European-centric model for both legal systems and responsibility and language. And what's quite challenging, I mean, we even do have emerging research that shows, I mean, you have higher bias in, you know, language, smaller resource languages. There's some interesting research that shows there's higher hallucination of legal principles for non-US jurisdictions versus US jurisdictions, because there's more US legal data in the foundation model training. So that's then going to be really hard when, how does a person in a lower resource community hold accountable the actual procedural aspect of, we might know who is accountable, but how are we going to actually enforce that? And I think that's what's going to introduce hopefully better regulation, like systems and structures that hopefully will help enforce the laws we already have.
Thank you so much.
I guess I was curious what you thought about tort law as a framework. Torts? Yeah. Do you think you have to look at who is in control of that particular part of the supply chain?
Yeah, I think that's definitely part of it. So tortious liability, again, is, you know, a very long evolving and complex area of law. Some of my favorite tort cases, you know, about a snail that ended up in a bottle, and another famous one's about a cricket pitch in someone's backyard. These laws have evolved through very strange circumstance. And we often come back to the principle is sort of who bears the responsibility of care. And I think that's actually a really helpful way to frame this question. So those are two parts of the question. One, who's in control? So that's often why I think a deployer is often going to be a first point of scrutiny, because they are the person that should be evaluating, is that model best for this context and setting? But there's also this sort of duty of care that we can't have these foundation model developers just recklessly saying, well, I didn't use it that way. but you did design it to be able to be used in that way. So you can't sort of evade responsibility just because you're a little bit further up that chain, I think.
Right. Since we're talking about deployers, I'm taking one question from the audience, which started beautifully. I love France. Is the choice of Mistral made on the basis of performance or the basis of politics/European sovereignty? And this was especially towards Tom and David. So this person loves France, but they want to know.
I guess we've heard a lot about Mistral today. Yes. This is not a plug for Mistral AI in any capacity in the same way it wasn't a plug for Anthropic. No. I do find that Mistral is a big European player in this space. For better or worse, some of the other big players, like the Google Gemma models, which come out of DeepMind, or Facebook's Llama models, have ended up being more US-centric, like after DeepMind was bought by Google and all of these things. So some models end up not being kind of as tuned to more European values and things like that, which I would imagine is closer to why you chose it. Performance-wise, it's quite hard to judge because the state of the art in like open source, open weight models changes on these benchmarks every week. So you kind of have to just choose a model, evaluate a few that will work well for you, and then go with it. And because if you just chose the best model and re-architected your system every week when the new model comes out, then you'll be stuck in that development cycle forever. But I have found, at least in my experience, the Mistral AI models are pretty good. Same thing with the Gemma models, but slightly different applications.
I think I have a very similar answer. So we have tried different models when we did the pre-training, like 1.5 years ago, and Mistral came up the best when we continually trained it on Norwegian. But then the second reason is also that it's a European-based company, so we would assume that it's aligning better with our values. Another reason for choosing it was the very open license without any restrictions. But the big problem of choosing Mistral is that while it's open weight models, so the weights are accessible, they don't say what data they trained on. So it's not fully open model, actually. So now we are steering more towards training on fully open models like Olmo, for example, that also give you access to all the data that the model was trained on, and then you can inspect it and maybe have some hypothesis of why the model is behaving like it's behaving.
Great, which takes me also to the next question that also comes from the audience, which was, can we ever fully align systems trained on messy data with idealized human values? Because we know that much of the data that is actually at the core of these LLMs comes, for example, from the internet, right? So, yeah, can we really align, knowing that they have seen that data and expect them to align with our human values?
Yeah, maybe I can the microphone. But yeah, there was a quite recent study that was very interesting, and what they found out that it's actually better to pre-train models on toxic data, because which is quite paradoxical. But then when you do it and you don't filter it explicitly, the model then learns better representations for this toxic data, and then during post-training, the model can more easily separate and sort of know what is toxic and what is not toxic. And then during post-training, it leads to actually better behavior in the end, because then it can more generally respond in a non-toxic way. So there are lots of this sort of unintuitive things when it comes to training models, and it's very difficult to say, I would say.
Okay.
Yeah, similar to that, and kind of coming back to the point I made earlier about like controlling and aligning AI models, all of this work is still kind of very brittle in a way and gives unexpected results. There was another paper that I saw that said that these like fine-tuning rounds of guardrails for kind of harmlessness can easily be undone in like only a few rounds of training if you just took a model and tried to make it bad again, which kind of goes to the point of it's very fragile to do these things. And we're still not there, really.
I guess this is like that question is also one where you really need to ask yourself, what do you mean by idealized human values? I don't think we are able to articulate our values. And when we try, we usually go wrong. It's well known in philosophy that sort of the leading, sort of the simplest, most intuitive at a principle level theories, utilitarianism and deontology, tends to generate really, really bad judgments. They don't work. When you try to make them so precise that they give you, completely specific answers, all the most plausible ethical theories are ones that have a huge element of judgment and contextuality that is not actually formalized in the theory. And I think this just reflects a fact about what values are. They are not like, it's not like we have secret rules in our brains or even sort of implicit in culture. There are things that are also evolving all the time and responding. And a value doesn't generate behavior in humans on its own, assuming we could articulate it. It also interacts with what we know and what we think and what other people do and how they respond to us and so on, so on, so on. So I think there's, so thinking that we are aligning with a thing that exists objectively, I think is not really capturing just how complex and organic, like human society, culture, values is.
Yes, and adding to that, another interesting question could be, how should we train human values? How should we make sure that we continue training our values now with these machines being a bigger part of our lives? To make sure that we can compare the responses of the generated texts with what we know is right.
Yeah, that's a good point.
Yes, on this I have just a small follow-up. I think it was you that mentioned that a law, for example, must be flexible enough to adapt to change. But this is also true for human values in general. So indeed, we should be flexible without maybe falling into absolute relativism, but still just having a degree of flexibility on how we evolve as a society. So crystallizing what is right and what is wrong might be not, of course, the right choice. So yeah, I would assume that this AI alignment is a process that grows together with us because we grow every day. So this system must be, in a way, flexible together with us. Yeah, just this.
Great.
Yeah, and just a very small comment to that. Shannon Waller has suggested some technomoral virtues, and flexibility is actually one of those. It was something that we really have to nurture in our time.
Great. So one last question before we wrap up that I would be very happy if everyone would like to answer. Which is, if you could enforce one requirement on all AI systems tomorrow, what would it be? You're free to say whatever you want.
Don't kill.
Okay, actually this question was in relation to one of the presentations where we were asked to, yours I think, yeah, to keep in mind what would be a very high, so now that I'm a philosopher, truthfulness. If we can make them just say the truth, that would be enormously helpful, I would say.
Follow-up, you mean searching for truth, right?
Yeah, so since the models are only based on our data that we have created, and I think that the big requirement should be that the models should be open and accessible to everyone, to help everyone, not be restricted in any way.
Yeah, and maybe not inherent property of the models themselves, but as I mentioned in my presentation, I'm a big advocate for content provenance. So if anyone has one takeaway from me, it's go and adopt C2PA, use watermarking, things like that, which we haven't got there yet with these technologies. They are fragile again, and definitely a lot more work needs to be done, especially in like the watermarking case. But if we could get to a position where all AI-generated content has some marker in it that it's AI-generated that anyone can check and is actually robust against being removed from that content, I think that would resolve a lot of issues we find, like both in the media industry, but also in education and things like that.
I'm going to say yes and what everyone else has said, but I also think it would be really impactful to have more explanation of uncertainty from AI models, because humans are still the people that are interacting with them the most. So the more that we can get a sense of how confident a model is, what it's uncertain about, what it's more confident with, I think that'll really help improve AI and human interaction.
Great.
Promote understanding, maybe? Like, I guess given my talk, I have self-interest in that being a very important topic that you should invest a lot of research money in.
But it's a really good point as well. So, all right. Well, thank you, everyone. Thank you so much for standing here and accepting all my weird questions and also the good questions from the audience. Thank you, everyone, for being here and joining us. I think that I, at least, as I said earlier, learned quite a lot, and I really enjoyed talking to all of you. So thank you again, and thank you for coming, and have a nice day.